Hello YouTube. Hello everybody. Let's get started. Day 14. Extended polymerization. Oof. The incredible pressures at this depth are starting to put a strain, thank you Benjamin, on your submarine. The submarine has polymerization equipment that could produce suitable materials to reinforce the submarine, and the nearby volcanically active caves should even be necessary. And the nearby volcanically active caves should even have the necessary input elements in sufficient quantities. The submarine manual contains instructions for finding the optimal polymer formula. Specifically, it offers a polymer template and a list of pair insertion rules. Your puzzle input. You need to work out what polymer would result after repeating the pair insertion process a few times. For example, NNCB. Okay, so you have an NN, and N becomes NNC. Okay, I don't know. Let's read how it works. Oh, NNCB, NCN. Oh, so N becomes NCN, I guess. CB becomes C. Oh, that's okay. I have to read it. The first line is the polymer template. This is the starting point of the process. The following insertion defines a pair insertion rules. A rule like AB into C means that when elements A and B are immediately adjacent, element C should be inserted between them. Oh, I know what's happening. So it's NN puts a C in the middle. And then it's NC maybe? We have NC. NC puts a B in the middle, so becomes NCNB. And then you have CB, which puts an H in the middle. NCN, NBH, NBC, sorry, PHP. Okay, I think I got the rules. I'll still read them, but... so starting with the polymer template NCB and NCB, the first steps, first pair matches the rule, so you add C. Second pair matches the rules, so you add B. Third pair matches the rules, so you add H. Note that these pairs overlap. The second element of one pair is the first element of the next pair. Yes. Also, because all pairs are considered simultaneously, inserted elements are not considered to be part of the pair until the next step. After the next step, after the next step of the process, blah blah blah, blah blah blah. This polymer grows quickly. After step 5, it has length 97. After step 10, it has length 3073. After step 10, B occurs this many times, C occurs this many times, H occurs this many times, and N occurs this many times. Taking the quantity of the most common element and subtracting the quantity of the least common element produces this number. Apply 10 steps to your pair insertion to the polymer template and find the most and least common elements in the result. What do you get if you take the quantity of the most common element and subtract the quantity of the least common element? Oof, okay. So we have another thing that likes to grow. And conveniently, we need to count. But to know how to grow it, we need to keep the string because there is some positional information. So like, what are we going to do if like can you compute step 3 without skipping around, without going here? Or rather, can you just do counts? So one thing that you can do is, let me think. First of all, is the naive version that bad? Like, if I just keep growing, okay, it grows a lot, fine. So it goes from 4 to 7, 4, 7. I think it's like a fixed number, right? Because every step, like, it adds a percentage of the original, something like this. Like, adds half of itself, I think. Is that it? That's 4 plus half of itself. No, more than half of itself. Okay, there's a formula. But it's a fixed growing rate. It's a lot. Like, you can see the curve even here. It grows a lot. To n minus 1. Thank you, Martin. What if there's no mapping for a pair of characters? I get you won't have to grow it, so it's gonna be, then this is like the upper limit in that case. But I think they probably will cover everything. Yeah. Let me look at my input. Oof. There's a lot of letters in here. Also, this is a lengthy starting point, but more importantly, there's a lot of letters. Okay. There's one thing that can be done, maybe, which is, instead of looking at the problem horizontally, maybe we can look at the problem kind of vertically, as in, so when you start with this, you have this n, right? And this n is gonna grow in ncn, which is then going to grow into nc and also cn. So, okay. So what I was thinking is, can you somehow, like, instead of doing everything at once, like the entire string, doing everything 10 times, maybe you could do 10 times a subset of it? I think yes, you can. Because you can do this, like you can do n 10 times, and you get basically this n up until, I don't know, whatever the heck the other n is gonna be. Maybe this. So let's say that this n grows, since it grows in the middle, it's gonna grow until there. Then you do nc, and you grow nc 10 times, and then you do cb, and then you grow cb 10 times. So basically this allows you to break the problem in chunks, and you can kind of see, okay, maybe I'm making a terrible mistake and there's like one tiny detail that I'm not accounting for, but you can kind of see that if it grows in the middle, then the two ends are basically the limiters, right? So look at this is the second n, then it goes here, then it goes here, then here. Actually, I'm not sure. No, it goes here, maybe, then I don't know. Here maybe. I think it's here, right? No, I'm wrong. It grows by 2 and minus 1. So it's gonna be. I think it's gonna be. I don't fucking know. This one maybe. I think it's gonna be this one here, and then it's gonna be this one here or something. So, okay, maybe it's not super easy to keep track of this, but Doesn't look like an exhaustive mapping to me. I don't know, we'll see. I mean, worst case, if there is no rule, you do nothing and you leave it as is. So I think this is the trick. Like you don't need to do the full string at once. You can do it in chunks. So it's another trick of transposing, right? We are transposing, I don't know, over time. So let's see. Let's try to solve this. Okay, day 14. So I'm gonna steal some code. Oops. All right, I'm not on a Mac. Always this problem. So do I need a hash map? So if I do, it's gonna be a string hash map, I think. Or maybe not. Maybe just an array of characters. It's better. So let me think. So I said that I want to do this in chunks, right? So basically, I want to do, instead of doing horizontally, producing an always longer string, I'm just gonna chunk this. I'm gonna do a depth first thing, right? If you will. It's like first we complete the NN expansion, we count. Then we do the NC expansion, then we count, and then we do the CB expansion, and then we count. And at that point, we're good. And we'll never have to keep in memory all of this madness. All at once, at least. Because I think after 10 steps, right? So we just need to do 10 steps. So the question is, what data structure do we want? I guess we want a hash map for the rules. Although we don't really, I think we can do even better than that. So I don't think I'm gonna do it, but here's the thing. We are reading this file at compile time, or rather we can do that if we want. Or rather, sorry, the file is always present at compile time, which could allow us to, also let me copy the input. Should I, you know what, maybe I'll do straight up my personal input. We'll see how it goes. So one thing that we could do is parse at compile time these rules and like make a giant like inline switch thingy. Maybe, I don't know, I don't think it's worth it. Hash map it is. Auto hash map. Oh wait, it maps so nicely to what we were already doing. But in this case it's gonna be it's gonna be 2 letters to 1 letter. Rules. N. There's no char type in Zig? Nope. U8 is your char type. So we start tokenizing then. U8 input. What are my separators this time? Oof, can I cheat? I think I can cheat. I think I can do new line and space, right? So while I hit on next, talk. Or also more precisely, here's another thing. I'm gonna do this const Unicode code point or Grapheme or Arch character. Oh yeah, that's a good point. Const base, I don't know what to call it, like the starting string is gonna be it.next dot question mark. So first we grab this from the tokenize. Then the second thing that we'll get is gonna be this, and so basically then the while loop always is doing the three items loop for each line. So talk is gonna be talk is actually going to be what am I gonna call each part of the rule? 0 to 1. Thank you for the follow. Welcome to the stream. Mark uses toke. What? Somebody needs to explain this one to me. Oh, that's the hat, right? I'll call it from and the other part too. So we're gonna basically do assert, or rather, if it.next dot question mark std.mem.equal u8 it.next arrow. Please let me know because I'm parsing the file in the wrong way. Also, why is this here? Okay. So basically, from then it's going to be this token here that we always match to make sure we are parsing correctly, and then we have const2 equals it.next not question mark. Okay, and we need to put this stuff inside rules. So try rules dot put from. Oh, here's the thing. So from is a slice, and we don't know for sure that it's length 2. And we are making the auto hash map with the values, like an array, a value type. This is not a pointer type. And worse, a slice is not a naked pointer, right? It's a pointer plus a length. So it's like it's a tiny struct. So we need to do so from is a slice. So from the slice, we need to grab the pointer. And then, as Specs taught us, we slice the pointer from 0 to 2, which will safely assert that this is actually possible, and will return a pointer to an array length 2. So we do dot star, and at that point we have on our hand the actual array, which is what we want to put inside the hash map. This seems a bit more complicated than it should be, but the problem is that dancing between stuff that you know are runtime, stuff you know are comp time is what you do. And I'm using tokenize, which is a very generic function which returns slices. Not all tokens are supposed to be the same length, right? So if I was using a different way of splitting, or rather, if I were to implement my own customized way of splitting this input, I would probably do a split that produces immediately an array of 2 letters. But since I'm not doing this, I'm getting back from tokenize, which is very generic, just a slice. And at that point, I need to massage my slice to have it become the precise type that I want. So that's why I have to do this dance here. Okay, so the value is gonna be it.next. And actually, wait, you know what? I don't need to do dot pointer now that I think about it, because I can slice immediately a slice. I'm dumb. I don't think I need to do that. I think I can do this directly. A slice can be sliced. That's why it's called a slice, I think, maybe. at least partially. So I don't think the dot pointer is needed. Actually, now that I think about it, maybe I never needed dot pointer in any of the others. I'll try to compile this to make sure I'm not going crazy. But I think I don't need the dot pointer. In any case, we do the next again. Can you drop the dot star 2? No, because this is not a slice. This is an array, and this, so slicing a pointer, be it a naked pointer or a slice, with statically known what's it called? With a statically known range, produces a pointer to an array of this size. And this dereferences the pointer. So if I didn't do, you know what? I'll drop it this so that you can see the compile error, which will tell me that the put function for this auto hash map is expecting this type, and instead we're giving it a pointer to this type. And Zig doesn't automatically go from pointer to value in that case, because there are some implications, like you could foot yourself in the foot very easily if Zig did that automatically for you. Okay, so the value is gonna be, oh no, I have it already, it's 2. So then 2, also 2 is also slice, but it's a single character, so, or rather, we just take the first element from the slice, and that's gonna be our U8, and that's it. In a sense, we are doing the same thing here and here. It's just that here we're getting one item out of the slice. Here we are getting a constant size array out of it. But this is a pointer, not the slice itself, at least as far as I understand. So maybe we can compile this and see if it works, except that we are not using base yet. So call std.debug.print. So I have to add this at the end, and I'm also using this as a way of using the base variable so that it doesn't complain. So expected type 2u8 found a pointer, a constant pointer more specifically, to 2u8. You see? So that's why we need to dereference that pointer. Boom, and now we reach unreachable code because I'm not parsing correctly. That's interesting. So what could that be? Do I not? What the heck? Oops. Okay, this is the first time that that this check actually triggers, and I wonder what's up with this. Like, usually tokenize is so well behaved. What do you, okay. What the heck? What the heck? What the heck? Am I going insane? Sorry, let me also double check that that there are like no empty spaces. Weird. Oh, it's missing not. I'm dumb. Holy shit, thank you. Okay, yes. If it doesn't equal, oh god, oh this is not gonna be a good night. I can already tell. Okay, so we got to the end. So also keep in mind that this is interesting. So if we were to not dereference, we would be giving a pointer to this, which is actually okay, but not. Because if you give to auto hashmap a pointer, what I think auto hashmap will do, it depends on how it's implemented. Like the auto part, it means that basically this hashmap is choosing an hashing and inequality function for you. But what it will do, I think it's gonna do like pointer equality to elements. And I don't want pointer equality, right? Because I'll have letters that are like somewhere else and I need to equate them for their values, not for the, like there's no identity semantics that I can use with letters. So that would be part of the problem. Also, if you make this a value type, it means that you can modify these without modifying the original. If you were to pass around pointers, you would be modifying the original. And even worse, since we are embedding this data inside the executable itself, the embedded data is going to be in a section that's read-only, so you can't modify it. You saw it earlier that what we were producing by not dereferencing was a constant pointer. So that's a pointer that you cannot write through, which makes sense because that's data, as I said, in a read-only section. So there's a lot of difference between passing around pointers and passing around to consuate. That doesn't make sense. That's not a thing, Matt. What do you mean? Yes, it does. It's not. Or at least I don't know. In maybe in C++, I don't know. In Zig, as far as I know, this is not a thing. This is a array of 2 U8s and what's a string literal? Dude, you should know this as well as I do. A literal is a pointer, a constant pointer to a whatever length is that string literal of U8s. But the pointer can be constant. The array is not constant. Thank you, Benjamin. So Matt, you're actually, so you're excused because you have to touch C++ Coda, you've been told, and I'm very sorry for your condition. So I wish that one day society would get to a point where sacrifices like yours wouldn't be needed anymore. But until then, thank you for your service. What was I doing? Oh yeah, so we were adding the rules. Okay, so we know all the rules at this point. So now we need to count each stupid element, right? So what do you get if you take the quantity of the... Oh, right. So most common element and subtract the quantity of the least common element. Oh my god. So I want an array hash map. Is there auto array hash map? I hope so. So I'm gonna do counts, I guess. Actually, I'm going to put it here. So counts is an auto array hash map. Also, the auto array hash map has to be different. It maps an element to a count. I'm starting to suspect that my insight, my original insight might not be enough, and there might be a need to do one more, like it needs to be generalized one step more. I'm starting to get this suspicion, but I'm not sure. I'll continue with now. I think that starting with a base of length 2 should be good enough. Because like you can see that your input is also being annoying because it's pretty long. It's not just a ton of letters, but it's also pretty long. So maybe maybe that helps. Okay, you're right. Thank you, Mark. But that's, you can see how it actually works out. It actually works out pretty well, right? Because you're given a pointer, so it's funny because you can do const foo equals banana, and you know that foo is a pointer, so you also know that inside main you will be storing. Oh, let's say that this is var. If I do const, it's kind of weird maybe, but if I do var, I know that foo is a pointer, so main inside its frame is only gonna need space for a pointer to do this. It's not going to store, it's not gonna need the space for the entire banana. It's just gonna need the space for a pointer to that banana, and that's kind of cool. Same with the input, right? If I do this, input, it's a pointer to an array, to a pretty long array of data. Well, relatively long. So it means that this input is not stored inside of main directly. Okay, maybe main is a special case, but like the same applies also to another function. So I think it's cool. I've been using concepts. Yeah. Thank you for your service. So we keep the counts in there, and then we have another while loop, I guess. Zig does not use arrow data section. I think it does. That's the point. Because it does that, then when you do what I was doing earlier with foo, foo is a pointer to that. So do we have a for loop or a while loop? I think we have a for loop. Oh my god, I need to... Okay, the hardest part, how will I be able to produce the pairs correctly? How will I produce the pairs correctly? I just need to increment I, and that's it. So that's fine. Okay, so var I usize equals 0. Then while we do I plus 1. No, I think I want to do I starts at 1, and while I is lower, it doesn't matter. I starts at 0, and while I is lower than what is it? Base.len -1, I plus equals 1. Then I do const pair is base sliced from I to wait, I know this trick. Wait. So there's a trick for producing a... So if I were to do I dash dash I plus 1, I think it needs to be plus 2 maybe. So the first two are 0 to 2 because this is plus 2. But then if I do this, this is gonna give me a slice, and you know what? I think it might be fine. But there's also syntax that I can use. Zig is not gonna be able to infer that this should be a pointer to an array of length 2, unfortunately, because there's like this expression. There's I is like runtime value, and we are messing around with it, and who knows? Somebody somewhere has a pointer to this freaking I, and they're doing weird shit with it. So. I don't know. Maybe it can, maybe it can't. But the point is, I don't know. Maybe in theory it could, but I don't. But it won't right now. So one thing that you can do is also do this. Like you slice from I until the end, and then you slice that from 0 to 2, and that is a slice where the range is constant And so it's known statically, and so that produces a pointer to an array of length 2. Do I care about this? I don't think I really care about this actually in this case, but it's something that came to mind because I think I saw this trick used by somebody at one point. Ooh, Prime Gen. Thank you for the raid. Hello everybody. Oh no. 300 people watching me fail on the advent of code. Hello everyone. Okay, so thank you for everybody that's following. I'm actually not failing yet. It's actually going well, but I should probably, since so many people are joining, let me tell you what Zig is very briefly. It is an advertisement. You're being warned, but also know that it's relevant also because that's the language that I'm using. So, what's Zig? Zig is a general-purpose programming language. It's manual memory management, funky metaprogramming stuff. And that's it. You can go to ziglang.org to learn more. That's it. Also, somebody was pointing out, where is it? Sweet Terminal chat. Yes, that's this beautiful, beautiful chat. It's called Bork, and I programmed it. And what would you know? It's a TUI chat application that can print emotes, and it also understands stuff like raids. I really need to make a release of this thing, because right now, if you want to use it, you need to compile it yourself, unfortunately. It's not hard, it's just that you need Zig, and if you don't care about Zig, it's annoying. And I'll get there. I'll soon get there. So if you do live coding and you don't have like a particularly fancy chat setup, I think this one is pretty neat. If you want to print emotes, you need to have Kitty, because it uses the Kitty image protocol to print emotes. So just so you know. If you don't, it's gonna just print, it's gonna fall back to just printing the emote name, which is, I guess, reasonable, but a bit boring. Oh, yeah, and so they're not animated because, yeah, this one is supposed to be animated, right? Let me look at that. Oh, they're all supposed to be animated, also this one. So the problem is that I think I'm not doing it correctly. I think they could be animated, but the protocol is, I think understandably kinda, it's like you can't just toss a GIF file to Kitty and then it will autoplay in a loop. You have to send it frame by frame and then give the terminal instructions on how to drive the animation. I think Kitty will be able then to have a bunch of animated stuff on screen, or like on the screen. I'm not 100% sure actually, because I've never done it. And I learned, from example, from iTerm 2 that image protocols occasionally can go really wrong. Like iTerm 2 also supports the image protocol, and that's what I started with. But man, it's a disaster. Like even having 4 or 5 emotes on the screen at the same time, it's gonna immediately make your terminal start lagging because it's implemented in a very inefficient way. Kitty is so much better from that perspective, even to the point where you just send the image once and then you can refer to it with an ID. So like right now I'm scrolling, and as I'm scrolling I'm basically telling Kitty to put an image in the new cell. Like there's no concept of scrolling in a terminal when it's in this mode. The scrolling is emulated by me basically telling Kitty to repaint everything. And but the images are not being sent every time. Images are only sent once, and then I can refer to them by name, let's say. Yeah, Kitty, by the way. Kitty on NixOS, by the way. So how did you get into Zig? So the story of how I got into Zig is that I was working at Redis Labs, which is now redis.com, I guess. I worked at Redis Labs, so I got a job at Redis Labs because I wrote a Redis module called Redis Cuckoo Filter. Where is it? Oh, there you go. That's me. Yay! So I wrote a module that implements Cuckoo filters, and one thing led to the other, and I got hired by Redis Labs. Then once I was, and I wrote this in C. I wrote my Cuckoo filter implementation in C, and it was I don't know. It was okay, but not the best. So it was such a mess. Now the C code is in a branch called C obsolete. It was such a mess. Also, the Cuckoo filters are a paid actor. Well, that's what developer advocates are. Wait, I didn't say yet what I was doing. I'm not working at Redis Labs anymore, by the way. But that's the story. So yeah, so I wrote this in C, but Cuckoo filters are, and I wanted to do like a bunch of like bit fiddling stuff to make it nice and efficient and whatever. But then it's a bit messy because I also wanted to have something like generics basically, but it's C, you don't have generics in C. So I started making this freaking macro with this concatenation operator thing. Like this macro stuff that I was doing, it's a mess. Like look at this final macro. It doesn't have to be this bad, but I wasn't an experienced C programmer, and I was going bonkers with macros. So like this is a chunk of a if condition that I'm basically macro expanding in place. Why does it have to be this bad? It doesn't have, but it was me. And I got to the point where I said, like, what follows is a micro nightmare. So I was kind of losing control over my shit. So basically, to maintain sanity, what I ended up doing is I wrote an implementation in Python that's like much more explicit. And then I basically had run tests that would run both implementations in parallel and check the entire memory space to make sure that the two memories basically would be equivalent after every single operation. And that was it. And I gave a talk about this. But then I found Zig one day, and I specifically found this, the in-depth overview. I found this originally was on the homepage. So I read the overview, and then I started reading about comp time and how Zig does metaprogramming. And I said, nice, I like this. And then I basically tried to rewrite this in this Cuckoo filter code in Zig, and I then also extracted it as a library. And man, the Zig code is so much better. I don't even know where to begin to say how much better it is. Well, I can tell you how much better it is. It's so good that I tossed away my Python implementation because I didn't need any more. Now I actually knew what the heck my code was doing, and so I was happy. So I'm not saying necessarily that C is that bad. If you're an experienced C programmer, you probably could pull off Cuckoo filters without going insane, but I wasn't. And Zig was a very nice learning curve in that perspective. So why was I doing also these things? Because I also, as a developer advocate at Redis Labs, needed to explain to people how to write Redis modules. And Zig was a very nice way of doing that. Because, well, I experienced that myself, right? So that's how I discovered Zig. Then I left Redis Labs, and now I work at the Zig Software Foundation. End of the story. Let's see. I hope I'm not the only one that mentally reads rediscovered as rediscovered every time I see it. I can tell you that somebody in marketing, like some genius CMO, use that as a catchphrase for a Redis conference. Discover Rediscover Redis Central, Rediscover Magazine. Redis Labs urges users to rediscover Redis as a database. I think this was published around the time when that conference came out. Yeah. So, oh my god. It's an old instance of the Redis conference, so I don't know if they have the assets online anymore. This stuff gets tossed away at the speed of light as soon as it's over, but whatever. Okay, let's do day 14. So, by the way, if anybody has questions about Zig, feel free to ask. I'm happy to answer all and any of them, even though I'm doing day 14. But it doesn't have to, I don't have to stay on topic too much. The whole point of these streams is actually to help people know more about Zig. What is Zig? It's a programming language. You can go to ziglang.org and you'll find it. Kappa. So we got a pair. Why Zig? Good question. Why Zig? You can see that people that subscribe to me for 16 months, they are like, so in the beginning, when you don't know anything, you ask what is Zig. Then maybe if you have been a while here, like Oscar Allen has been, you know, how you start asking how Zig. But then when you're like a long time subscriber, you ask why Zig. So that's when you're reaching the enlightenment stage. Okay, so we get our pair for our stuff. So for each pair, we need to run the function that produces 10 thingies, and then count everything, right? So how we're gonna do this? For each pair, we need an array list, don't we? I think we need an array list, because the point is that I'm basically doing. Let me think about this. So the way I originally tried to do this exercise was, instead of expanding everything, so for people that weren't here that don't know exactly what the request of the day is, we have this string, and then we have a bunch of rules that look at the string 2 characters at a time and tell you what character to put in between. So the first 2 characters are n, and we have this rule that says n needs to expand into ncn. Then the C that you just added, you ignore it for now. Like, it's gonna come into play into the next loop, but into the next iteration of the whole string. So then you look at NC and you do the same, and then CB, and then you get with a longer string, and then you do it again. The problem is that the string grows a lot. So the question is, how do you cheat? And one quick answer that I came to was, instead of doing everything horizontally, you look at the first couple and then you just expand this one. Also, you need the counts at the end, you don't need the entire string. So you expand only these 2, which will still expand to a lot, but hopefully by starting from just 2, they don't expand too much. And then you do the same with NC, and then you keep the counts, and then you do the same with CB, and then you keep the counts. Linked lists. I'm not sure if linked lists would help me much here. The problem with linked lists, especially on a 64-bit architecture, is that like your pointers to the other elements of the list are pretty big. And like if I have to have a bunch of things like this, I kind of want an array list, I think. But I want to avoid that as much as I can. So what the alternative that I was thinking is, what if instead I just go, what if I were to discard the second n? Like I do nn, and I say, okay, that gives me nc. And then I do nc, and that gives me nb. And then I do nb again. And then I realized that NB gives NB, so I'm done with this. BB produces BN. There's probably loops in there. Oh, wait. Okay, there's also the other trick that I didn't think about. Okay, maybe I'm overthinking the first half. Maybe the second half is going to be more problematic. Another way that you can cheat is by somewhat pre-processing these rules, so that instead of having to apply these rules every single time, you have like a more synthesized version where like you can basically apply 3 of them at once, and you know what will come out of that. I don't know, in any case. In any case, I hope that my trick of just starting from a pair is gonna be good enough. I hope. Because otherwise, how am I going to do it? We'll see. Okay, for each pair, I need to do this a given amount of times. So var iterations. These are like the overall iterations. We have to do it 10 times, I think. So don't overcomplicate. Yeah. Well, but I think it's good to think about it briefly, even if you're not going to do it, because like originally I didn't think about manipulating the rules at all, but also manipulating the rules is a good idea sometimes. So basically I think the idea would be that what you would want to do is find like stable rules so that you know that when like NB expands in NBB, right? Okay, so yes, expands in NBB. Yeah, that doesn't help. Okay, never mind. Let's continue with the with the normal strategy. So while oh man, iterations. Iteration. Why do I have? Okay, let's. You know what? I'll use J. So while J is lower than 10, we increase J. And what do we do in there? We actually do the normal expansion for this pair. So we need an array list. I think I'll create it outside and then I'll reset it at the end of every iteration so that I don't like reallocate it every single time. For I don't know, buffer. That looks almost like a for, almost, except that in Zig fors only happen on arrays and slices, and we don't have a for loop for ranges. If you want a range, you have to do a while loop. So my array list, what do we put in there? I just put bytes and that's it. So at the beginning of each loop, we do buffer dot, what do you know? Clear retaining capacity, that's it. So basically clear retaining capacity empties the array list, but it doesn't free the memory. We keep the memory around, which is, I think, good, because actually we know how, I haven't computed it, but we know how long each of these things is gonna be, I think. So we're basically gonna keep allocating, we're gonna keep reusing the same memory. And actually, you know what? At this point, I don't really need an array list. I could actually maybe done something better, but whatever. Okay, so we need to put the pair inside the buffer immediately. So what functions do we have to add stuff to an array list? Time to look at implementation. This is the Zig standard library. So public function init, public function init capacity, the init from own slice. Oh, I like this. Array list takes ownership of the passed in slice. Oh, but the slice must have been allocated by an allocator. That's not our case. So no, we'll need to copy the stuff inside. Initialize is an array list and managed with the items and capacity fields of this array list. To on slice, insert. Insert item at index n by moving list n dash dash list n to make room. This operation is linear. Oof. Insert slice items at index I by moving to make room. This operation. Wait. Oh, that's what we want. We want to insert slice, I think. Or actually, do we also have append slice? Pen remove, swap remove, append slice. Okay, so in the beginning we can do just append slice, and then we have to do insert. So buffer.append slice pair. So this is gonna be our starting point. And then for 10 times, oof, here's the problem though. We want to iterate over the array, but we're also modifying it at the same time. So I was originally thinking of doing something like for buffer.items but the problem is that as we append stuff, as we push stuff inside, it's not really going to work. I don't even know what happens if I modify this as I'm looping over it. Like, will this for loop recompute what the length is, or will it just keep assuming that the length is the original one? So, not knowing this, and I think the point is in general that for loops is not what we want. Ours is the new SDF, yes. Well, it's the Colmac version, right? So it copies the pointer and lands into a temporary, so we don't want to modify this stuff basically. So they won't change during the loop. That's bad. We need another while loop, I guess, because we need to manage our own index at this point. No, well, I think Martin explained it. It will result in something that we don't want. I don't think this is the problem, because we are, well, actually no, never mind. You know what? It actually could result in this because it copies the pointer, and as we append to it, this stuff is gonna get reallocated. Will potentially change pointer, and so we are like at one point we're gonna be trying to access a dangling pointer. That's not nice. So we need another while loop and another thing. Oh god. Okay, we're like 3 levels deep. That's not nice. P, I don't know, for position. Funny thing, I don't need this J at all. Size starts at 0, so while P blah blah blah. While P is lower than buffer.items.len, we increase P. And actually, we know that we need to increase P by 2, because at every loop we're going to insert a letter, and then add an assert that to make sure that we actually do. If we don't, I'll change this to be +1 and then add another plus something to P in case. Okay, so this should be accounted for. Then then we need to apply the rule, right? Oh wait, actually, so wait. This is, yeah, that's a good point. Is this P1 or P2? Let's call it P1. And that needs to be like this, right? Because it needs to be like this one. And so we want to do that, our pair. Oh my god, also we have this annoying pair here that's like stealing the pair name, but I want to reclaim it, so I'll delete this line. Now we can have a pair inside here. Oh, that's part 1. Sorry. That's, I mean, okay, you know what, I'll take this out. But yeah, what I was thinking of is that, what I realized as I was doing this is that I need again to do this. pair equals buffer dot items p dot p plus 2. So this is a pair, and in this case I actually do care about this being a proper array, so I will do the slicing trick in this case, because right now this is a slice. So right now the type of this is const u8, because right now we don't know that this is actually of length 2, or actually we could, but Zig doesn't. So let's do this. So the first slice is going to basically be a suffix, while the second slice is going to be a fixed length slice. And now the new type is this. And we can also do dot star, which makes this now. But we don't need to specify the type. Okay, so we do this. Then now we need to find the rule. So const expansion is going to be rules dot get pair dot question mark. So this dot question mark is going to panic in case we don't find this rule. So this is gonna tell us if there are actually for real pairs that don't have a rule. And if that's the case, then I'll need to account for that possibility, which is that occasionally we will not be able to put a new letter in the middle. Is there actually no for loop in Zig? There is, but the for loop, a normal for loop, so okay, let me do the final thing. Oh, with this syntax, no. You use a while loop with this syntax if you want to do a for loop like this. Like, it's kind of the same, as in, like, this condition and then step, you do it in a while in Zig. That's the only difference. Or rather, that's the main difference. The other difference is that a for loop has also an initialization part. Our while loops don't have an initialization part, so the initialization has to go outside. No, it's not possible online because of that. By the way, thank you for the follows, everyone. I haven't been thanking you, but there's been like a ton of follows, sorry. So, pair expansion. Let's do it. Let's put this stuff into into our buffer. You could put it into one line if you want, I guess. You could put also the body into one line if you want, I guess. Yep. So, oh, was it? No, it wasn't append slice. It was insert slice. I feel like this insert slice work that I'm doing is actually not good, because I'm moving data around that I probably could not, like, that I wouldn't need to move if I knew what to do correctly with my indices. Maybe, like, you could basically maybe reorganize this while loop by, instead of grabbing two letters one after another, you know how far deep you are into the looping, and that tells you where to find them in an array where you didn't put them in the right place. But whatever. Append slice, assume capacity, append slice. So items and then void. So how do we do this? We make a slice. And so here's what I'm doing basically. This syntax can coerce to an array. I'm basically doing pair 0, then expansion, then pair 1, which is what the assignment asks, and then I take the pointer from that, and that hopefully should give me a slice. And I could do this more explicitly, like I could also do it like this. This is an array of 3 const u. Wait, I'm doing the math thing. Don't be a math. Okay, this is an array of 3 bytes, and then I'm taking a pointer from that. But I think you can omit the type and just do dot, and it should work. We'll see. So the index, what's the right index? The right index is it's p, right? We put stuff at position p. No, it's position p plus 1. You know what? I think it would be nice to actually print the buffer as we modify it, just to see. Is this it? So this is it. Okay, I don't know if this was actually part of this original question, Crazy Wolf, but just to complete. So the reason why I am doing a while loop here again and I'm not doing a for loop, like a normal for loop on my array of data, of bytes, is because I'm modifying it as I go. So I need to have control over the indices. Okay, so this stuff keeps modifying it. You know what? I think I just realized that I'm dumb. So I was saying that this insight could probably be generalized more. So my insight was, I don't do this horizontally, I just do it in chunks. So I first do this 2, then I do this 2, then I do this 2. But I could actually generalize it more, I think. As in, I always do left, and then I always do right, and then I move forward. So I do NN, that gives me NCN. Then I do NC, which gives me NBC. Then I do NB, which gives me NBB. And then I do NB. And then next loop I do NN, which gives me NCN. Oh no, that wouldn't work, because then I would do CN, which gives me this. But then I'm gonna miss all DB expansions. Never mind. Okay, so we insert the slice in there, and then we need to do counts. When do we do counts? When do we do counts? Do we do counts at the end? Also, how do we make sure we don't double count the initial array? I think we should count only stuff that we insert, only the expansion, and then we do one count of the original one. Yeah, we do one count of the original string, and then we do. Yeah, that works. Okay, so this is the expansion. We add it to the slice, and then we do the counts. So counts, we do counts dot. So this is interesting. Okay, my input is letters, uppercase letters. I'm actually tempted to do like an array and increase an array instead of having a hash map for counts. I think that's what I'll do. So I'm gonna make counts std.mem.zeros of what? Of a 21. Size array, and then counts is going to be counts position expansion minus a. By subtracting the a character, I should get to a value that is in the range 0.21 ideally. Well, 0.20. There's no z. There's a lot of letters missing, so well, it should be, there's gonna be holes, but it's fine. Who cares? Let me do plus equals 1, so this should be fine. And we do it 10 times and we're good. And then result is gonna be well, actually we can print the buff, we can print the counts if we want. We should sum them up. Bar sum usize equals 0, and finally we're able to make use of a for loop to do something. And this is gonna be our sum. I think we still need some kind of diagnostic here to make sure we do the right thing, but at the same time it's not that complicated, so this should be fine. So we keep growing, keep growing, keep growing. We do it 10 times. We keep counting what we're expanding. This is the hard part. Are we doing this correctly? We start at 0, and we continue until p is the second to last element. Ooh, wait, is this correct? I think it is. It's, I'm not sure. You know what? Let's just run it and let's see the counts. You know what? Maybe let's start with this. There's 26 letters in ASCII. Oh, thank you. Then I'll change that. That's a good suggestion. Oops. Error is ignored. Consider using try. Yes. I think it's this, right? This is gonna allocate memory, so yes. Error is ignored. Oh. Append slice. Oh yes, of course. Expected type usize found a pointer to a start. Okay, so this didn't work as expected. So first of all, what usize? This is not what I expected, but also this pointer to struct is, wait, what? Oh, parameters are reversed. Wait, what? Append slice. Insert slice. I mean, of course, I was somehow convinced that I was sure I saw that the I was the second argument. That's why I wanted to double check. Okay, but memory. So let's put p plus 1 here. And it seems that this expression put in the right place. Oh shit. Oh shit. Is it really that bad? Wait, I'm not incrementing something I need to increment. Can it really be that bad? Okay, you know what? I think I'm gonna print. I think I'm gonna print at the end of this loop. Oh no, at the beginning of this loop, I think I'm gonna print the buffer, I guess. Unbelievable amounts of main copy happening. Oh, is this really going to NN? I think there's something wrong in my logic. Like, even if there are so many main copies, hi Megan, even if there are so many main copies happening, there's clearly something wrong in my implementation here. So I guess I'll need to print stuff also in here. I think I'm iterating. Yeah, it's an infinite loop. I think my plus equals 2 is wrong. Maybe it's plus equals 3 or something. I don't know. Like, because the problem, you can see that we are trying to increase B, but we are also, you know that I'm a complete moron. We don't need to insert slice here. I said it correctly earlier. We need to insert just the expansion. These stupid things are already in there. Yes, thank you. Yeah, I actually said it correctly earlier. Then I forgot about it. Like, as I was coding, I forgot about it. And basically what was happening is that, like, we were growing the thing more than it was progressing the P, yeah. So N, N, C, N, B, N, C, N, N, B, C, C, N. I don't know, that seems 30, 69. Oh wait, it's not the, wait, it's not the final count. It's not the total count. We need to, okay, right. Right. Okay, I need to sort these values, take the biggest and the lowest. Step 1 is missing H. CHB. Well, where do you see that it's missing H? Because it's doing it 2 at a time. So it's first expanding an N, then it's expanding an C, then it's expanding CB. So the H is here. Or I don't know if you're referring to something else. I don't have to do the sum. I forgot. The final length should be 3073. Okay, but I'm not even count. Oh, actually, I am doing the length. Am I? I'm counting the repetitions of everything, but the total sum of the repetitions of everything is, oh, you know what? I'm missing the original length. So the original, I kept saying that I'm gonna count the expansions that I'm adding, but I'm not counting the original elements. So 3073 plus 4. Sorry, not 3073. What was my answer? 3069. 3069 plus 4 gives 3073. So that's correct. The count is correct. It's just that's not what I need to do, right? What I need to do is sort this stuff, which I did in the past. So I'm gonna steal my code for sorting. Did we really not sort for that many days? Day 10? Sort, or would you look at that? Yes, there we go. So we need to sort counts. And we sort from lowest to highest. So here's the thing. The highest is going to be the highest. So const high is gonna be counts.len minus 1, and that's it. But the mean is gonna be more complicated. The mean is not gonna be the first item. The mean is gonna be const mean. It's gonna be the first item that we find from, starting from the beginning, from the left. That is not 0 because we have a bunch of cells that are set to 0. So this works like this. If C is greater than 0, then we break with C. Otherwise, we continue, and if you don't find anything, it's unreachable. Like, come on. I mean, it's a fair thing. Like, the language forces you to like have a solution. So the else branch of a for loop in Zig runs when the for loop didn't break, when you didn't break from the for loop. So the idea is that basically with this syntax, your for loop is a search. You're searching for something. If you find it, you break from it, and you're good. If you run until the end and you didn't break from it, it means that your search failed, and so you need to have an else branch to return like an alternative value, which in my case is going to be unreachable because I'm assuming that like I don't have a fallback strategy. If we go here, there's something wrong with my code. So unreachable is fine in that sense. So then we want to do high minus mean. Mean. Let's see. Count. What is it? Counts. Counts. Of course it's counts. 1587. 1588. Why? Of course, because I still haven't added the original string. God damn it. So let's add the original string before sorting. For or just a +1, yeah. So where's the original string? The original string is base. For base, what is base also? Okay, base is just a slice. We can iterate on it directly. B, we do counts B minus uppercase A plus equals 1. And that should make everything work. 1588, yes, 1588. Okay, let's go with our actual input. So this shouldn't be too bad then, because our actual input now we are dominating it. Like, even though there's a ton of rules, which means that I think in section 2 we're gonna do something with these freaking rules. Even though this is much more long, this is not gonna increase our memory consumption. We're gonna still have the same exact memory consumption as we had with the test data. Oh, why is this open? So do I need to do something in here? Yes, I want to not print this so that it just doesn't print a bunch of garbage that I don't care about. 2170. That's not a lot. Let's see. Oops. That's the right answer. Cool. Okay, part 2. The resulting polymer isn't nearly strong enough to reinforce the submarine. You'll need to run more steps. A total of 30 steps should do it. In the above example, the most common element is B. The least common element is H. Apply 40 steps. So, will 40 steps mess my thing up? So here's the thing. The trick that I did where I don't do the thing horizontally, but I just do it vertically, it's a trick that can be reused multiple times. It's like, I think the more generalized concept of what I'm doing, I think it even might have a name that I don't know of, but like it's when you mix breadth and depth first search together, and like there's a bunch of strategies that mix the two approaches together in like an unstructured way. You could try it and watch memory usage. God damn it. I mean, memory usage is up here. What's the memory usage when running this? It's so fast. You know what? Are we YOLOing 40? I think we should YOLO 40. Why is this counter not going up? I would expect this to go up considerably. Uh, yeah, so how do I open a new terminal like this? Sig. It's using a ton of CPU. Okay, it's increasing memory usage a bit now. Yeah, insert is not helping at all. So, oh no. Good point. Okay, let's start. Dash O. Let's go. I still think that that's not going to really help, right? So I really need the go down trait to be more generalized. What's a good way of doing it though? When I tried last, oh, you know what? That's a good point. Why am I not even printing? I should print at least that. That's good. Maybe as we think about the solution, we can watch it run. And also, this is gonna be so this is gonna wait. So this is gonna tell me which couple we're looking at. And okay, so let's put it here, right? No. Yeah, okay, so this is gonna tell us which couple we are looking at, basically. Couple starting from index 0. I think we're not getting out of that couple 0 anytime soon, because once we get out of that couple ID 0, we are getting to couple also. Okay, so we need why is it dash O release fast and not D release fast? That's a good question, because the command line argument and the build system use different conventions, and so like if you use run directly and you're not going to the build system, you do it like this. Why are they not like homogeneous between the two systems? That's a good question. I don't know the answer. Should they be homogeneous? I think that would be nice. I don't know why they are not right now. But I can also tell you that I think that right now the state of all these command line flags is not like, they haven't been polished. They are, I think, a mix of Z conventions plus copying conventions from other compilers. Like for example, I don't know, there's like some flags with a single dash in front of them, like this one. Well, never mind, no, this is actually a single dash because it's a single letter, but there's also dash target, which is a single dash with a full word, which normally would be dash dash target. I don't know, I think they haven't been like, these command line flags haven't gone through a full polish pass. That said, yeah, Martin is right. There's this big difference here. I still think though that like, I mean, shouldn't it still be the same? So we're not going out. We're not getting out of the first couple. So that's bad. So what do? I think we need to formalize the concepts of going down and going sideways, so that we decide how much down we want to go and how much sideways we want to go. Or maybe I could try and see if insert. So let me try something. Let's assume that I was able to. I knew what to do with the indices, and so instead of insert, which moves data around, I did append. Just to save some annoyance. Would make this any better? I think it wouldn't. I think 40 is too strong of a number. We need to attack that 40 and break it down. And probably even just cutting it in half. Like, out of curiosity, would 20 be reasonable? 20 is super reasonable. So even just cutting it in half, right, would be fine. So what we could do is 20 is 1 megabyte, it's fine. So maybe one thing that we could do is just simply expand the original string 20 times and then do it by couples. So we do 20 iterations horizontally and then we do the remaining 20 vertically. Since 20 seems reasonable to do. Although this is 20 from 2 letters, it's not 20 from a longer string. But whatever. So, okay. Does it work also with insert? Oof. Oof, wait, really? Is insert really that bad? I'm still at 20. Wait, what? Is insert such a monster? Oh no! So I need to also solve insert. Okay. So we don't do insert, we do append, and then we fix the index afterwards. So we do append. Oh my god, my brain is going to explode. So my pair is gonna be something more complicated than this. My pair is gonna be buffer items something and buffer items something else. Let's do it like this. Okay, so one is gonna be P, and we know, but the other one is gonna be where? P, no, it's gonna be at the length, the original length. What was the original length? Wait. Am I dumb? No. I think I'm dumb. I think this one is gonna make me go crazy. So this looks at the string 2 things at a time. This takes the original couple and keeps expanding it 20 times. So we start with an n, and then we have ncn or whatever, which in my case would become nnc. so the second. Oh no, don't do it in this way. What do you recommend, Martin? Down this road lies only madness. Used to list, okay. Oh man. That's fair. But I wanted to be clever. Yes, of course, if you use the list, you don't modify it and then it's fine. That's true, but it's more memory. What if I could do this though? Okay, I'll do two lists. Use a slab allocator. I think I'm doing like this, like buffer temp, something like this. Or just temp. Actually, this probably temp goes in here. Okay, let me think for a moment how to use the temp, the temporary thing. So what I want to do is copy everything into the new array, right? I want to copy everything into the new array as I go through it. So instead of doing append, I basically instead of doing buffer.append, I do temp dot append the expansion, but then so I just copy. I can do append slice, I guess, or I can do two appends. I'll do append slice. Of what? Of pair 1, expansion. Also, I messed this up. It needs to go back to being normal. That's buffer dot items p dash p buffer dot items dot len Okay, so I got my pair back to normal, and when I append left plus expansion, right? Yes, I keep appending slash plus expansion. I don't append the right side, but I think I need to append the right side at the end, because the final one needs also to show up in here. So once I'm done looping, I'll have added everything except the final one. So I do try temp dot append buffer items dot len -1. That's the final one. So that should have copied everything over, and then I flip them, and then I do buffer equals temp. Ooh, I need to flip them around, and I can't lose temp. So var t equals temp, var equals temp, temp equals buffer, buffer equals t. And I swap them, and then we start again. We reset temp. Okay, will this give the correct solution? Result 76. I don't know what that even means. It should be, this is 10, right? That 76 is suspicious. Wait, let's go back to this input here. Result 5, but that's not, it wasn't supposed to be 5, was it? Yeah, it was supposed to be 1588, so we did something terrible. Nothing terrible happened. Did I miss something? Okay, for counts, buffer, temp. So we start with NN. And then we do 10 loops on NN. And it's gonna start with, well, just NN, I guess. Oh wait, the +2 is wrong now, because I'm not pushing stuff into that same thing anymore. This is a normal thing. Actually, now it can almost be a normal for loop if I wanted it to be. Almost. Okay, so we increase by 1, and that's it. 539. That's not actually it, really. What else am I doing wrong? What else am I doing wrong? Oh, is it correct that I'm clearing temp? Am I clearing temp at the wrong moment? I'm doing 10 expansion loops. On each expansion loop, I iterate the entire string. I copy the entire string into piece by piece into my temp thingy. Then I append the final item. And then I swap them. And now temp is what was previously the buffer, which gets cleared. What am I missing? Ooh, I know what I'm missing. I need to make these pointers, I think. Oh my god, I think that if I want to swap them, I think I need to swap pointers around. I can't swap, I don't think I can, so I think that this gives me a struct, and I can't move that struct. I think I have to do pointer stuff. You're fine to move that struct. Okay, so do you see any trouble with how I'm swapping them? It has no self pointers. Okay, it's interesting, thank you. If that's not it, then what is it that I'm doing? Okay, let's think. So we start with NN. We clear temp. Temp was already cleared. Then, for each element in buffer, we do from P to the next P. So we do P and P plus 1. Didn't you mean P plus equals 2? Originally, yes, because I was adding the expansion in the same slice itself. Now I'm not modifying the slice the buffer anymore. I'm putting stuff in another temp thingy. So yeah, let's see if there's something clearly wrong there. So N and CN, CB and CN. No, where's my left N? I'm leaking letters to the left. Why? Why am I leaking letters to the left? Examine a pen slice closely. Oh, right. I'm such a moron, thank you. Because I wanted the first, I said clearly, I want the one to the left, and then I put a 1, because in my brain, first 1, of course. Okay, now it's... I think this number is wrong, actually. No, it's correct. Okay, so we're back to normality. That was a dumb mistake. Okay, so we are fine now. Let's remove the print. But here's the problem though. So we still can't do the 40, I think. So we need to do the expansion. So these expansion stuff, I'm gonna straight up copy paste it out here. Boom. And I'm actually going to put it inside the scope because otherwise this J and this J would, like, that J would shadow this other J and Zig would complain. So this is the horizontal expansion, and we're gonna do like 20 ticks of horizontal expansion over base. Ooh. So here we are. Okay, so we do. Okay, it's fine. We do this stuff in buffer. So base now it's var, because we want to change base. We are going to not count anything in here. We are going to expand. We're going to copy. We're going to do try buffer dot pen slice base. So we're going to put the base inside buffer. Then we're going to do 20 rounds of expansion. This is going to use temp and buffer a bunch of times. We get at the end, and we get our 20 times expanded buffer. So let's put a print in here that says done expanding, so that we know how far along we are. And then after 20 rounds of expansion, we do 20 rounds of depth. And this should be like a more balanced cut point. I guess it's the most balanced cut point. Let's see how far we can get. No. No. Why? Oh, because I forgot one important detail. So yes, we're done expanding, and then after we're done expanding, we need to basically make the contents of this buffer become our base, which is what we are doing here. So how do we do this? We need to copy, I guess. What's a nice way of doing? Oh, there's two own slice, right? What is two own slice going to do? Two own slice. The caller owns the return memory, empties this array list. Wow. So we do base equals buffer dot to own slice. There we go. So now it's ours. Buffer is empty again. Okay. So this is proceeding. Wait a second, though. Done expanding. Give me also the length. Or you know what? Print this slash Just a bit of progress. I think this is good enough. I don't know, could this be improved dramatically? How long is this gonna take? This is gonna take a while, holy shit. Maybe the cut 2020 is not... Maybe the cut 2020 is not the optimal one. Maybe we can do something better. Like, we can do 1525. Actually, what's better? Is better to put more here or more there? I'm not even sure about this. So this is going to lower a little bit this number, but man, our iterations are so slow. Let's go in the opposite direction. So let's keep doing 10, and here we do 30. I don't know. Are you in release fast? I am in release fast, yes. $30 might be too much. 30, we're having trouble expanding. Oh. I'm having trouble counting how many digits are there, but I think this might be good. Can I take back control over my terminal? So it's like 2, 4, 6, 8, 10 digits. 2, 4, 6, 7 digits. There's still a lot of stuff. 5.3 gigabytes being used. That's still kind of slow. So what can we do to improve this stuff? Let me think. What can we do to improve this stuff? You really think it's my terminal that's really bottlenecking this? Okay, let's try. But so if I modulo, let's do every 10,000. Oh, every 1,000. Okay, we print every 1,000. Yes. Blah blah blah. Now it's gonna take a while to pre-calculate the thing. I should output it to a file so I don't have to wait this step every single time. So 3 zeros are done. So 2, 4, 6, 7 digits. 7 digits out of 10. So it's like 7 digits out of 10. That's what? I don't know. It's gonna be a bit of time. So can we... Okay, let's see. So I don't think the bottleneck is the terminal, Matt. I mean, surely it's not helping, but yeah. How big is the impact of printing all that stuff? I think it has a little bit of impact, but the reality is that this is clearly something that takes a while to complete. There's a decent version that goes 10 deep on pairs like this that is fast enough, but it's difficult to think. Oh, I see. Yeah, so like the optimal thing, I don't know either. Do these things not have a name? Because I know the general concept of mixing breadth and depth first to kind of do what I'm doing here, right? But I don't remember if I don't think I have ever seen like a formalized discussion around how to use that specifically. and what properties to expect, and like if you can somehow make a, like, I'm sure that there is a formula that you can, like, we know that the growth is 2n minus 1 per iteration, so from there the actual solution does have a formal name for its family of techniques. So let's see how many digits. 1, 2, 3, 4, 5, 6, 7, 8 digits. I'm gonna have to stay here a while if we don't find something to speed it up. This is only for 10 in depth and 30 in width. And we could make these 35 and then this only 5. But I don't know actually if I'm trading in the right way. Honestly, like also 35 probably is way too much. Like 30 is already taking a while. I can probably do 31 and maybe this 9, but I'm not sure if I'm doing anything better. What I could do is, like, instead of doing one horizontal and one down, I could like cut them up, like do a bit of wide, then down a bit, then wide again. Something like this. Like, if I could mix and match deep and wide, maybe I could find like a better curve. I don't know. But also, maybe improving this part would help. That doesn't make anything faster. Making the second pass faster increases the number of seconds passed by the same amount. Wait, what? That doesn't make anything faster. Making the second pass faster increases the number of seconds passes by the same amount and they cancel out. I'm not sure I can parse your sentences. So I think you're saying that making the second part faster makes the first part slower, and so... Oh, you're thinking the same also when doing a mix of these things. Maybe. Maybe compute how long it would be the string if we would do all 14 passes. Well, it's too long. It's a lot. Like, if you make the second part 2 times faster, you make the first part 2 times larger. So you would need to do 2 times more second passes. So what can we do to make this better then? Let's see. So the append slice is not that bad because we are always clearing the staff retaining capacity, so we really don't allocate. We could do append slice assume capacity if we were to instantiate this stuff to the right length. Oh, wait. Also, I think that what else can we do? I can think of any algorithmic improvement to make this faster. So maybe... Oh, I didn't think about doing anything with the rules. Maybe simplifying the rules would have helped somehow, like preprocessing them. Maybe I could have memoized larger chunks. Like, also have rules for triplets? No, I don't know. I'm not sure. So let me look at the rules. So CH expands into CHB. So 2 loops basically expand CH into... Oh, you know what? I could have basically... I think I could have applied the rule instead to this. I could have applied the rule. I could have applied the expansion to the rule themselves. But that basically CH becomes another string. And so I know that when I find a couple in the original thing, I know immediately what to expand it to for 10 increments or something. Basically memoizing, in a sense, the going down. So the idea of touching the rules was actually not that bad, now that I think about it. Is it worth doing it? Or am I getting there? 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh no, but these are 10 digits, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Maybe we can raise against this thing. So the idea is, instead of doing anything here, we do 10 expansions to these. And then we basically replace these. I should have done this also for the first loop, because that's basically what I was thinking of, just a better version, because I'm memoizing the progress as I do it. We can do even better. We don't solve it even faster. So let's see. So let's see, how would this look like? This would look like doing doing a given number of expansions, not from the base, but for each rule. You know what? I should have known better. In Advent of Code, touching the rules is always the right idea. When you have a bunch of rules, touching the rules, it's the good idea. So I need to basically mess around with the hash map, I guess. Should I implement this as a separate function at this point? You know what? I'm not gonna break this. I'm gonna make a new one. I guess we can call it this main one, because actually it did solve the first part reasonably well. Okay, so how is this going to work? I guess this part basically we can copy. I think there should be an array auto hash map. I don't know if we have the type. CD or ls cd AOC. No, I'm wrong. CD AOC. Yes. Day 14. Run main. Yeah. Okay. Unused local variable. Okay. Base. I guess I can print the base. Also, I think these are unused right now. I just want to see if my array hashmap thingy exists. But I see a non-member array how to hashmap because it's auto array hashmap, I guess. Okay, auto array hashmap. There we go. Okay, so we have this. Then We parse everything. Then we expand the rules, I guess. How do we expand the rules? This is the general procedure to expand the rules. We need to do this multiple times. So we need a for loop outside. So for rules dot what? For rules dot oh damn, and for 40 I think we'll need to. Okay, this is gonna be interesting. I don't know precisely how this is gonna pan out, but we'll see. So for rules dot iterator. So this is gonna give me an entry. Oof. So what do we want to do for each of these? We basically want to do this. So for each iterator we want to do, well, we want to reset the buffer. So buffer dot clear retaining capacity, and then we want to append in the thing what entry dot key pointer key pointer is not really a slice though, it's a pointer to an array, but I think it should coerce. So it's going to be key pointer, is that correct? Yes, we put that in there, and then oh, this is gonna be interesting. This is gonna be definitely interesting. Also, why do we need the buffer? We don't need the buffer. Okay, this entire architecture needs to change. So, because we can do this iteration here directly on the entry. Okay, I'm starting to think about so I need to make my changes into another hash map. I can't modify my hash map right now because then I don't know what I'm doing anymore. Although maybe there is a funny way of doing that in place. I think there is a way of doing that in place. Basically, the idea is that oh, also this has to change type. Basically, this also has to become, oh, this has to become a slice. Oh my god. Oof, this is going to be interesting. Okay, I see. By the way, how are we doing here? Oh my god, could this thing beat me? Also, I need to go to the restroom for a brief moment. I'll be right back. Hello, I'm back. Hey, one lives left. Thank you for the raid. Hello, everyone. Sorry, you raided me as I was on a break. So, well, my break was actually that's T negated. It's the opposite. It's inverse. But I also have T. How's it going? Not good, actually. Because I did part one by. Well, I don't know. Did you do the Advent of Code already? Were you doing it right now? Yeah. Okay. So basically, here's what I did. I had this semi-genius idea of doing the original string one couple at a time and going deep, which was good enough for the first half. But for the second half, for 40, it's not really good enough. And so basically, I now got to the point where I realized that I need to basically memorize all the intermediate steps. So put them into change the rules, basically, like process the rules instead of processing the string. And so I was about to do this, while in the meantime, I'm racing against my dumb implementation with a split. So I basically expand breadth first, if you will, 30 times the original string, and then I do, sorry, where is it? Stars. Okay, so this is the main function that it's running right now. So 30 times expansion horizontal, and then from there on, I go deep 10 for each couple. And I don't know, it's going, but 2, 4, 6, 8, 9, it's like there's one full digit missing. So I'm racing against my dumb implementation, basically. By the way, is his memory ramping? No, my memory is not ramping because it only ramps up in the first half where I'm expanding horizontally. The breadth first expansion consumes RAM. Sorry, it's this one. The vertical expansion, the depth first expansion, keeps utilizing the same memory, so it doesn't consume any extra memory once it allocates initially. So my memory usage is stable here at 5.4 gigabytes. Oh, it's a factor of 10 away. So I'm racing against it, but actually there are good chances that I'll be able to finish before then. So that's how it's going. So we have our rules. Where is it? We have our rules, and for each rule we need to apply the expansion stuff. But now that I'm thinking about it, this whole logic is probably can be simplified, but I think it needs to be flipped out, in and side out. So like we do one expansion pass per full iteration, and then we do this multiple times. Like there's no point in expanding one rule 10 times. I could do it, I guess. I know, but let's not do it. I think there might be bad implications. So, you know what? I'm just gonna cut this out. I think there's stuff that I want to save from inside here. But I'll need to restructure everything. Turn the CPU into a heater. Yeah, it's. I mean, it's fine. It's an M1. I'll survive. So for each rule, I think basically what we need to do is put everything inside a new array hash map. So we need to do a temp version of that. So we have temp, and that clear retaining capacity basically needs to apply to temp, I guess. Also, I don't know if temp has clear retaining capacity, so let's go find out. Basically, I was using arrays first, but now I need to use a hash map. Do I need to use a hash map? I think yes. So, hash map implementation, where is it? Hash map. We do clear retain capacity. What do you know? Same API. Nice. I wonder who worked on this API. They did a good job, in case they're in chat. Good day, long time since I have seen a Zig developer. There's actually a bunch of people streaming Zig lately, so let me point out actually to other people streaming Zig in case you want. So twitch.tv/KubeCon. So this is Jacob Konka, and he's working on the Zig linker.
Okay.
So I actually recommend him if you want to watch somebody doing like proper compiler work. He's working on the Zig linker for cross compilation and stuff. And he actually started streaming today. That's also interesting. So today was his first stream. Was this sent correctly? No, this was not sent correctly. Is this better? Yes, this is better. Then who else? Then there's Tiger Beetle. So this is interesting. So Tiger Beetle is actually like okay. I hope that the song is not gonna give me trouble. So Tiger Beetle is this. It's a database. It's a distributed database written in Zig, and basically here you have Isaac Freund and Joran working on a well, it's in the title, new storage engine. So they're writing on a storage implementation for the database, or rather a new implementation of that. So that's cool. Oh, there's also community stream section. Nice. So I don't know. These are two recent streams. Like Tiger Beetle started streaming what, last week, Friday, or so. I don't know if they are already included in that page. So check them out. Also, Megan is streaming. So Nectro77. Well, that's easy because that's our same handle. Then there's also Andrew RK. Is it Andrew RK? I don't remember. Andrew Rock, right. There's also Andrew Rock, who is, I guess, hosting me. Okay, but I don't know. So he made the language, so he's probably another good stream to look at. Then who else is there? Specs is also streaming occasionally. Where is Specs? Okay, so you know what? I'll end here because I can't remember everybody. But you can also do this. You can also go in the Discord server. There's the Zig programming language Discord server. You can find that an invite to that from the Zig website. And in there's a streams section, and every time somebody streams, they make a post there. And it's not just that. There's also Suzy, which is a bot that basically puts you in this live now category whenever you're streaming. Whenever somebody's streaming Zig. So that's also nice. So there's a bunch of Zig streamers that you can watch. And that's really impressive. I remember trying to make a game engine back in 2020 using SDL, but I heard of it only because one of my friends from Godot Discord server recommended it to me. I see. Yeah, there's a lot of activity. Also, this chat thingy that you're seeing, it's written in Zig. So if you want to be a Zig live coder, you can have your own, your full Zig toolkit. Somewhat. Okay, so we have our temp hash map. We emptied it. Then we what do we do? Also, why do we empty it for every rule? That's not it. That's our outer loop that we haven't set up yet. So we need our outer loop. I'm gonna put this stuff into a scope. Var I usize equals 0 while inline while statement with a variables. Nice. I lower than I think it's what, 10. Well, we decide how much we want to go deep with those rules. Oh, I think it's nice because if we do 10, then it means that we do 4 expansions of this and we are down to 40. I think. Okay, so inside this while loop, that's where we have our for loop. Okay, so every time we start a new loop, we clear our temp stuff, and then for each entry, we want to do we want to apply the rule basically. We want to do also 10 is probably wrong because we are going to do something different. Is it correct to apply these rules like recursively? I think it's a good idea. Like we double it every time. That shouldn't be a problem. So like doing, let's say that we do 2 iterations of these. So if we do 1 iteration, we do 1 increment. If we do twice, we go to 4. So it's 2 to the power 8, 16, so we could do 8 and then do 5. We could do 8 and then 5 of depth. That would work, I think. We'll see. So there's also the string thing though, that it's kind of annoying here. How do I do this? I could make this immediately max size. Am I thinking this correctly? I'm not even sure I'm thinking about this correctly. Okay, let's continue and then I should probably print whatever comes out of it. So for each entry we apply the rule to the entry. Yeah, it's gonna go on for a long while. It's basically just fun to have it in the background. So as I was saying, entry, so we apply the rule and or rather, let's get the pair out of the entry. So pair entry dot key pointer sliced from 0 to 2 dot star. So that gives us an array of 2. Also, yeah, that is correct. Then, I think. Ooh, Guy Royce. Hey Guy, thank you for the raid. Oh no. So these are basically, are these all raids from people that have already solved the advent of code? And I'm actually lagging behind, and everybody who's raiding me, it's basically flexing on me because they already done it. Yeah, those are all shame raids. Oh no. God damn it. So we have the pair, we apply the rule, we find the expansion. The expansion is going to be rules. Also, here the expansion, it's not going to be a single character anymore, but it's going to be a slice. I did the E3 today, I have shit to do. Okay, so now what do we do with this? Because I know the general idea that I want. Thank you for the follow, Java Grant. So are you doing part 2? Yes, I am. I'm doing part 2. So I know that I kind of want to pre-process the rules, but I haven't figured out yet how exactly I want to pre-process them. Because like, okay, let's say that I do a run of CH. What does it mean doing a run of CH? Should it become CHB? I think I should not be pre-processing the key. I should be processing the value, but then the value is what? You can expand the value, right? So how is it going to be? So I think I needed to keep a copy of the original rules. Kick my ass. I had to kill 9 my node process. Ouch. Yeah. So it's tough. I can give you a rundown of what I know so far. So I was able to do part 1. And the trick was the following. If you just expand it horizontally like this, it's gonna grow a ton. So one trick that I thought of immediately was, well, instead of doing 10 passes horizontally, I do 10 passes on each couple. So I go, if you will, down 10 times. I keep the counts, and then I proceed to the next couple, and I go down 10 times. And then again. And that got me past part 1. But then part 2 wants 40 steps. And 40 steps doesn't work. Or rather, going down 40 steps. So basically, the idea of going down from doing one couple at a time is that you avoid building a giant string. But if you want to go down 40 steps, then you end up with a giant string anyway, even if you're just starting from NN. So what I ended up doing for a bit is hacking a solution where I basically tried to like expand 30 times horizontally my original string and then go down 10, and that's what's running in the background, but man, it's gonna take a while to get there, so that's definitely not the right solution. And that's when I started thinking, well, instead of applying the rules to these, I apply the rules to the rules, and I basically start expanding the rules so that what ends up happening is that you memoize, in a sense, on the rules themselves, the progress. And that's what I'm doing basically right now, while in the background my ugly solution is running. So I'm basically racing against my bad implementation. In theory, you should be able to win, but you never know. and that's the state of things. And now I'm actually learning for the first time what it means to apply the rules to the rules, because I have a vague idea, but I don't know yet. So let's see. Malais Left is saying, part 1 I just did the string replace. It doesn't grow out of control in 10. I see. So basically my smarty pants idea was completely useless anyway. So So it ended up being like a needless, a useless optimization for the first case and not good enough for the second case. God damn it. So I was kind of hoping that like finding a better split point would allow me to push through, but that wasn't good enough anyway. So okay, so what does it mean to apply the rules to the rules? I think I need to have, as I was saying, what is it that needs to grow actually? Do I need to do like CH from B becomes CBH? But then those become the keys? So I don't know what applying the rules to the rules means. I'm actually trying to learn this right now. So should I do n becomes NCN? And then what do I do the next loop? That's clearly dumb. That's not how it works. So I think I need to expand this. So I need to do a new rule set that has CBH at the key. What happens to counts as each rule is applied? Counts. What happens to counts as each rule is applied? We increase by 1 the extension. That's what happened to counts. Or rather, we increase to 1 the counter corresponding to the extension. So I think that if you're saying this is because you're pointing out that I don't need to actually materialize the strings, but I don't see how I can avoid materializing them. Because, or actually I do see that. I think I do see that. Maybe. Let me think. Because I start with the NN. So the problem is that I start with an N, but an N becomes NCN. Which means that I need to do discount on NC and CN. So the count in like I can not put this stuff in a data thing, but then I would do something recursive. CH, CBH, CH, BHH. If you apply it iteratively, does that help you? Yeah, I have no idea. No, it doesn't really. I think there's a different type of thing that has to be done to the rules then. I guess. What can you do to the rules to make it nicer? What else can you do to the rules to make them nicer? You can... So an NCB ended up being... An NCB ended up being, after 5 steps, it has length 97. After that it has length whatever. Taking the quantity of the most common element and subtracting the quantity of the least common element produces 1749 minus 161. So is there a way of like knowing an n how much to what count it ends up being, and just store that count somewhere somehow, and then just add the numbers? But that's in a sense what I'm trying to do. The problem is that, so clearly you need to memorize something that you do somehow in between. I'm not just seeing exactly what and how. So I know that n. So let's say that I'm asked to do only expansion. I'm just doing. Okay, let's look at this. I'm asked to do one expansion, or like let's say I'm asked to do two expansions. So this is my target. I can do this expansion down, and that will tell me that n gives basically these counts for these letters. I don't know how much, but basically it ends up being these counts. Then I do the same for NC, but the problem is that I cannot go down 40. But it's fine, because I can go horizontal for a while. I can go down 10 once for each rule. I think I got it. I go down 10 once for each rule, and I save the freaking numbers. And then when I need to scan the line, I can actually go down 20. I go down 20, I save the freaking numbers, and then I expand horizontally 20, and then for each of these 20 I just add the stupid numbers, which should take a moment, because the problem is that my original implementation here, so actually my implementation wasn't wrong, that wrong, let's say. So basically, so we want to have then the split 2020, I think, because this 20 was reasonably fast. So we do this 20 only once on the rules, we save that somewhere, and then this becomes just an addition, I think. So let's toss this away. Okay, man, that was an interesting combination of things to do. So, okay, I actually feel better, because it means that like my nose led me, like my gut feeling led me kinda in the right direction. And I knew that at one point you needed to touch the rules, but I didn't know how to touch the rules. So that's like the meta game knowledge, because I learned how Advent of Code works from last year. But I'm happy that my original approach wasn't completely horrible. There are better solutions, but this one should be fast enough. Okay. So let's do this one. So this is 20 worth of horizontal expansion. Fine. This doesn't exist anymore, but instead we want to do 20 of vertical expansion for each rule to save the counts. Yes. And then this becomes a stupidly fast loop. So this expands the thing. Then we want to do, oh, let me open a scope. So then we want to basically go down 20 for each rule to make each rule correspond to the freaking memoized number of how big they are. Wait, but didn't Andrew say that recomputing is faster and then you shouldn't memorize? Then he lied in his talk. Okay, let's do it. So I guess we need in a hash map, I guess. Rule scores. You should never memorize except you need to memorize. Yep. I'll try. You know what? I'll try to keep that in mind. The size, whatever. I don't know how big these things are going to be. Okay, so for 20 times, this for each rule. I thought about spending $100 on AWS Compute. Hey, I mean, sometimes if that's the answer, that's the answer. Although I don't know, you know. I'm actually running on a good M1. I'm the only person using it. Like, this is taking a while anyway. I think this one, you shouldn't trust the AWS solution architect if they try to sell you compute to solve this problem. Why is my thing not working? Oh, because I haven't done this. Okay. Thank you. Okay, so for each rule, and I think I can do rules dot. Actually, no, it cannot be a for loop because my rules are auto hash map. So I need to do this var it. Can I do this, or do I have an it outside somewhere? I have this it, which is annoying. So let's call it read rule it. I think there's a key iterator or something. Key iterator, there we go. So while read.next, so we get a rule. I don't know key iterator what it gives me. It's gonna give me a pointer. Fab function. Is it a function or a constant? I think it's a constant. Key iterator. It's a field iterator over k. Okay, what's a field iterator? Okay, it gives me an optional pointer to the type, so we get a pointer. Okay, rule underscore ptr, so that we know exactly what we get. So we get the rule, and for each of these freaking rule, we basically want these. Do we need temp? We need temp. Yes, we need temp. Oh, this is doing the temp buffer swap thing that we definitely do need. So okay. These variables are fine because I'm already doing them somewhere. So it means that here we need to not here, sorry, in here we need to do buffer dot clear retaining capacity and buffer dot append slice rule pointer. Okay, let me double check this. So this works. This needs to modify a temporary buffer. It needs to keep flipping between a temporary buffer and a buffer that is less temporary, because it's gonna live for the entirety of the processing of each individual rule. So we do this loop 20 times, we go down 20 times, and at the end we save the score. So we do oh my god, we need like a temp score thing. So annoying. Where's my score stuff? Oh, it's counts. I can reuse counts actually. I can use counts and then I reset it at the end or something like this. Let me think about it. No, I just accumulate everything in counts. Maybe. Let me think. And actually, I can do it here. Oops. I was already doing this, so let me think. I add 2 counts as I expand. And that's good. And that's it. I think we don't need to do anything else. We clear temp. Oh wait, that's the first expansion. We do it here too. Oh wait. What am I doing? Oh my god, too many things with the same name. We don't touch this. Leave that alone. We don't touch that. Here we do the counts. We put everything in counts immediately. Yes. No. No, it has to go inside the rules course. Rules course, not. Oh man, this is so annoying. It's like get or put, I think. So because we need to save these partials in a place where they're indexed by the rule, because we need to then aggregate these partial counts based on whenever a rule matches. So we need a hash map. So it's gonna be get or put, and our get or put of what? Of the rule that we just matched, which is the pair. And we need also a default value, which is 0. Then, can we use entry, or are we using entry somewhere else already? I think we are good with the variable entry. So entry is going to contain a value pointer. We do entry dot value pointer plus equals, well, value pointer dot star plus equals 1. I feel like there's something wrong with what I'm doing. Maybe, maybe not. Because previously we were adding this core to the letter that we were adding. So we were indexing by the letter itself, but now we are doing looking at this from another angle. And yes, basically what we are saying here is, yes, NN will produce one letter when applying this rule. No, I don't think that's correct. Or maybe actually it is. Maybe actually it's the same, and actually this is just inefficient. I think that why am I not just waiting until the end where I build the entire buffer? So the end of this loop will have built a buffer large that corresponds to 20 iterations. Why am I not counting the result? And that's it. Have a good dinner. So yeah, I think there's no point in, maybe this also works, but that's not what I need to do. Like that's not the best choice. I think the better choice is we just build the entire buffer and then we count off of it. and we assign that score to the original rule. Okay, now things start making more sense. Oof. So we do var total, or actually the rule total. Is 0, and then for buffer.items we have a buffer.items nothing, it's buffer. Okay, we already have the count, it's the final length. Also, so rule scores dot put, oh my god, yeah, you don't need to do anything weird with it, just do this. We put in there for rule pointer dot star the value buffer dot items dot length, the length of the resulting string. No, because we need to count the individual letters. So the value here for each rule is not a usize. God damn it. Okay, I'm finally getting there. Bit at a time. Is the same type as this. It's a stupid array where we do all the buckets. Okay, so we need to compute the buckets, which is what I was doing here by counting stuff here one by one, and then we assign those buckets. Okay, I see why this is complicated. There's a big mind shift that you need to account for. So these counts, I think we can I think we can put them here. So let's call it rule counts per rule. Well, it doesn't grow, so we can just create it in here. So here we create counts per rule, and we do what we were doing here, which is this thing here. Okay, so we build all the counts per rule, blah blah blah, 20 times. And then we copy it inside our hash map. There we go. So this gives us the counts to apply for that rule, expanded 20 times. Perfect. We do this for every rule. We do it for all rules. This should then have rule scores filled with all the partial counts for each letter up to 20 times. We have expanded 20 times the original string. At this point, we process the original string, and processing the original string means what? Processing the original string means we don't need the buffer anymore, I think. Just need to have the pair. Oh no, what's happening? I think Sublime pooped itself. Am I having trouble with my... Okay, you know what? I think we can stop this, right? 2, 4, 6, 8, 10. Holy shit, it's 1/3 of the way through. I think we should stop it anyway. Please, Sublime. I think my Sublime pooped itself. But you're not third of the way there. Yeah, I know. I think my Sublime died? The heck? I don't know. No process found. Oh my god, what is it called then? Is it here somewhere? I don't even see it. Okay, you know what I can do? What happens if I do Command W? This isn't a tragic situation. It's like okay, does anybody have a suggestion? How am I supposed to find the process for Sublime? PS grep, PS aux grep Sublime. Yeah, I already did it in the past apparently. So kill all Sublime, is that it? What's the name? Sublime text. Oh my god, I'm having trouble understanding where the heck it's okay. So Nix store blah blah blah. Sublime text for bean slash Sublime underscore text. That's it. So it's this but with an underscore. No. With a 4? No. Kill all Sublime text doesn't work for some reason. Okay, that worked. Whatever. So I want to open Sublime. Is this going to be okay? No, I don't think I can do this. I need to do I need to call Sublime here because I needed to inherit my shell configuration. Okay, are we good? I think we're good now. I don't know what happened with Sublime. Okay, I lost completely context of what I was doing. Oh my god. I feel like I'm going back to when I was working with C# and it would take like 15 minutes for a compile to... like compiling the freaking solution. So this is when I'm running through the string and aggregating the counts. So clearly something went wrong with the AOC when manual process killing is here. But the funny thing is that it's the editor. Like the thing was running still happily, actually. Somehow Sublime had trouble. Maybe I was running out of memory, I don't know. There's a bunch of like overcommit happening on this machine. And it's not like just Linux, because I'm on a Mac host and I've seen this thing overcommit a ton, so who knows. Looking at it, expanding all rule pairs is more work than expanding the input string, I think. So you're saying that a different split could be preferable instead of a 2020? You think it should be something different? Input is only 11 pairs, but there are more rules than that. Yeah, but I cannot... I'm not sure I understand where are you going with this, because I think the problem is, like, the length of the original input isn't much of a problem. The question is, how much... So, going down 40 of even a single rule it cannot be done. You need to go deep less than 40. So I think that 20 is like a good number. Like 20 is kind of like how the deepest depth that you are willing to go on the rules. Maybe it's even a bit too much, which basically means that you need to expand the original string 20 times. It's like the 40, you can decide how to balance it, but that's pretty much it, I guess, maybe. So we get the pair. And also I think it would be nice to have this also when we are expanding the rules. We could do it like this, I think. Const rule len is rules not count. I don't remember. Let's assume the count is correct. So as I was saying, you print this. Don't need this thingy. Okay, we found the base. We found the pair, and then we basically know that our final solution, so final counts, which is counts up here. So I don't think we need counts anymore up here. So I'm gonna take it out because we are not going to use it. We don't use it here. We don't. Here we do the partial stuff in counts per rule that goes inside the hash map. Counts becomes a thing only actually down here. And so what we do is we do basically we find the partial. Partial is going to be rule scores dot get pair, also dot star. We do dot star. Yes, I need this to, so this is a slice right now. I need to make this a pointer to a fixed length array. So it's base.len and then 0.2. Can I please have expect a semicolon? Okay, fine. Okay, we get the pair. We assume that the pair is there. That gives us our partial counts, and then for partial p comma I, we do counts slot I equals p. Oh, sorry. Plus equals p. Oh my god. Okay, I'll get there. Plus equals p. So we start accumulating everything. We start calculating everything in counts, and that's it. We do it for everything until we get to the end. We have everything in counts, and then this is adding in the base. Do we need to add the original base in there? We don't need to add the original base in there anymore because we are counting the letters them. Oh, no, we don't. So what we were doing here needs to happen. Actually, it's fine. I think that this should still give the correct solution. No. No, it won't, I think. It definitely won't. It won't give the correct solution. So we need to make sure that we count also the base correctly. Can you listen to this tune for a month in succession? But I think everybody has to listen to it for maintaining succession. I don't know, I find it funny to have Christmas music for the advent of code. That's why I'm doing it. So we need, so when we were counting in here, we were adding counts per rule. This, we basically need to add to each rule counts for the rule itself. So here's what we do. We need to do counts per rule. Counts per rule. Oh my god, can I have that? Thank you. Hey Jacob. Hello, hello, hello. Minus plus equals 1. Twice. To what? To slot pair. Well, not exactly pair. What is it? The original rule. So rule pointer. So I can do this. I can do rule pointer slot 0. So this, like, let's say that the rule is n. This is going to be n minus a, and the same is going to be rule 1, and that's it. And so this will add to counts for this rule, also the rule itself. Me an idiot, obviously. Welcome to the club. Good thing that you don't know what happened up until now on this advent of code session. Okay, so this should in theory work. Let's see if it works with this tiny input. Like now the problem is, so I think that in terms of performance we're good. Now the question is, does it work in terms of correctness? So let's say that I do 5 and 5, which is the equivalent of doing 10, right? So now this should work correctly and do what we want it to do, and go back to the original solution. I think I don't even need release fast anymore. Use an identifier I. Oh, I cannot have I. God damn it. Why can't I have I? Because I'm doing stuff on an iterator. So annoying. Var read underscore I size equals 0, and this is gonna be read I, and here we have a continuous expression that all it does is just increment read I. There we go. So we have our nice thingy. Read the conditional called variable I. God damn it. Wait, what? Where? Where? Line 91. Yep. Okay. That's actually fair. Except that I type found 25 view size. Right, why did I put zeros in the type definition? Zeros is basically produces a zeroed version of that type, but I just wanted to put in the type. I don't know. Okay, more errors. Error is ignored. Append slice, line 56. Fair. Error is ignored. Consider using try in my scores. It's down here, I guess. That is also fair. Result 1620. That is definitely not correct, right? Because there was, so doing 10 loops, where is it? 10 loops of it was supposed to give 1588 and it didn't. So we're doing something wrong there. Oh no, I introduced a bug. That's not nice. Why though? Why though? Something wrong in the compiler did yell. Well, compilers can't yell at something wrong always. Compilers cannot catch logic errors. Like, the compiler doesn't know what I'm trying to achieve. So if I messed up some logic, that's on me. Are there any tests? Not really, because this is a rewrite that I just did. And the best test is, or rather, the best test is the small, tiny test input and see how well we do that, basically. So let me think. Is this wrong? This basically is going to add... I'm kind of thinking that maybe I shouldn't do this. I should really just do the entire buffer and then scroll the buffer and read everything in place. So you know what? I think I'll do it. I don't think that that's gonna fix my problem, but I think that's what I'll do it. So this is going to like the result of this where is it? This iteration should be the actual complete string. So we should be able to do for buffer.items dot that's it, buffer.items. So it's gonna be like a character and an index, and we want to do basically this counts per rule character minus a plus equals 1 every time we encounter 1, and this should give us, it's kind of the same at this point, but it just seems better to me. And use loop capture. Why do I not care about the index? I definitely do not care about the index. That's correct. It still gives 1620. Okay, so well, at least it's not the correct answer, but at least this is this seems to be correctly like a transformation that I think makes things nicer. And it didn't change what we were doing before. So the error is probably somewhere else. Can you add some midway checks? Yes, I think I'll do that now. Basically what I'm gonna do is that I'll print the buffer here at the end. So I'll do it like this, like string and then arrow. Why not? Oh, you know, maybe I should do like new line. That's better. In case it's kind of long. So basically this will give me... This will tell me this rule has been expanded to this string. And I can check if that makes sense or not. Too few arguments. That's fair because I need the rule. Oops. So, is correct that NB becomes NBB, 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 blah, 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 blah? I'm actually not sure. That's expanded 5 times. Am I building this incorrectly? Where were the rules? So, NB... Also, wait a second, what the heck is NB? Oh yeah, right, I'm expanding the rules, I'm not expanding the original string. So, the rule NB becomes NBB. NB becomes NBB. And... okay, then NB becomes NBB. You know, it's hard from the final string. I need to print also the partials. I think that's a good idea. So how do we print the partials? We print the partials here by printing temp. How am I gonna do this? So this should probably become something like this. And then here we don't print anything. So this should also print like all the partials. Let's see. NB becomes NBB, right? Right. NBB becomes NBB, and then B becomes and then BB becomes NB. Is that correct? BB becomes BNB. There's something missing. Am I? Ooh! I now remember. There was some code to copy the last character, right? I think that's what it's missing. Could it be? So because NB becomes NBB, but then that leaves an NB, and this BB needs to become BNB, and I'm missing one character. So there's something wrong in this expansion code because. Oh, it's strange though, because I'm doing this and then copying the final over. Why is this not happening? Middle B is reused, isn't it? Well, it shouldn't be the case. So there's definitely something wrong in this code from that perspective. I think I need a button break, and after I'm back, oh my god. Hey, Iridescent Rose, thank you for the sub. Thank you for the gifted sub. Okay, give me a sec and I'll be right back. AFK. I need to find something better than T. Inverse of T. And this can probably be 3 minutes, I think. Be right back. And I'm back. So, and also, you know what? I think I want to see it. So let me pull everything down. Okay. So, why are we not expanding good? Why are we expanding bad? You know what? Let me do this only for the first rule. Nope. Attempt to use null value. Oh, because sorry. Yeah, that's okay. It's not break, it's return. that's fair. Okay, so NB, NBB. Like, the first loop is fine. Why is the second one borked? Because the first loop, this doesn't increase. The problem is that when this runs twice, it runs wrong. That's so interesting. And also, this seemed to be working earlier. Can you show the expansion again? You know what? I can do better. I can print, I think, these intermediate values and see what's up with all that. I think I need to make these all strings except the expansion. I think it's string, even though it's just a character, I think S is fine. Or maybe not, maybe I was wrong. Format, what's the problem? Unsupported format string for type usize. Wait, what? Oh yes, this is a digit. That's fair. Okay, what's the problem now? Unsupported format string S for type U8. Oh, come on, so it's character. Whatever. So strict. Okay, so here, NB, position 0, pair is NB, expansion is B. Position 0, pair NB, expansion B. Position 1, pair is BB, expansion is N. So this should put BN. Was I doing this stupid thing earlier too? So I'm kinda confused. So in temp, I mean, it's fine that to the temp array I just append pair 0 and expansion, because then later I'm appending pair 0 and the expansion. Can anyone explain what is he trying to do now? Yes, I'm missing a character. So basically, somehow my expansion code now doesn't work anymore. Seems correct to me too. Okay, so NB expands if you apply the rule to NBB. Then you do the next iteration, and your string is NBB. So you first do NB, which should expand to NBB, and it does. And then you do BB, but BB should expand to BNB, and it doesn't. Or rather, it seems that it does, but there should be another B in the middle. There should be like a third B in here. No. No extra B. Let me look at the example code here. So is there an NB that we can use as an example? So this NB here, NBB, NBB, NB, NBB, NB. Oh my god, am I dumb? Have I reached the point where I'm starting to like I'm starting to question like basic stuff that I was supposed to know. So let me write this down seriously. Okay. So let me do it like okay, whatever. A new thing like this is fine. So NB becomes that's what we were expanding, right? Yes, becomes NBB, then becomes NB becomes NBB, and then BB becomes... What does BB become? BNB. Why am I missing something so big? The windows overlap. These windows overlap, but am I not expanding? I need to add 2 characters, right? In this loop. In this iteration, this string needs to be 2 characters longer than this one, right? 1, 2, 3, 4, 5, 6. Oh my god, it's 3 characters longer. What am I doing? So it should be 5. Okay, so it's correct. Oh my god. Oh my god. Okay. So this is what happens when you stay on the same problem for too long and you can't solve it. NBBNB. Okay, so if these expansion rules are correct, then why are my counts off? The last B of NB is the first B of BB. I guess. Why was I understanding this correctly here and I'm now not understanding correctly anymore? N becomes NCN. NC becomes NBC. Oh my god. CV becomes CHB. Oh my god. What do you know? Okay, so this expansion is correct then. So aside from my insanity, then it means that these expansions are correct. Pair 0 and B, pair 1, BB, BN, and B. We know what expansion is. So this expansion seems correct. It also starts with an N and ends with a B, which is good. So this should be the full partial count for this rule. So I'm guessing that if this is correct, then the problem is here. It means that I can't just do this. I can't just... Yes, N means that the middle B is used on the first pair and the second. Am I doing the wrong thing then in the second half? It seems that this part is fine. Actually, if I were to do... You know what? We have like a funny test for this. I go down 10 times for each rule. I don't expand at all. So I leave the original string. I leave the original string. I do 10 expansion of the rules. And this should give me the correct solution. Oh my god, enough please. Okay, let's maybe not print all this stuff anymore. Oh, also, you know what? No more return. So actually I can keep printing. Okay, 1588. Okay, so it gives me the right count, which means that this is correct. If I want to have this just do 5 iterations and have this do 5 iterations, what is it that I'm doing wrong then? Here it's the same exact expansion rule, so I'm actually... So it means that I am expanding correctly here. But maybe it has implications here. What implications does it have though? So basically, I guess the problem is, so this is correct. This is just expanding. This is correct because it's giving the right numbers. It's how I'm aggregating the values that I guess it's wrong. I think the problem is actually in the second loop, not with 10 and 0, but with 10 and 0 it doesn't show up, I see. Why is ZigRegEx not utilized for this problem? Unless you're thinking of a solution that is completely different than what I'm doing, why would I need ZigRegEx? Like, is this about... Like, why? Wait, what? Aren't regular expressions about matching? They're not about expanding. I mean, I guess there's a relation there, but normally regexes are for matching, right? Not for expanding input. But also, yes, you can like just expand the string completely. You need to be smart about it. So what am I doing wrong in aggregating the stuff? So Martin is saying that the problem is here, but it doesn't show up if you do all 10. Just to be clear, Martin, when you say second loop, you mean this one, correct? The one that for the rules course? Because I was thinking that, so you're saying think about how the chunks get put together, yes, and this is the loop that I was thinking is wrong, but you said second loop, and this is the second loop, or at least that's how I interpreted it. Did you mean this one, right? Because that's where I thought the problem was. Okay, no, you mean the loop above that. Oh, okay, so you were correctly... Okay, so you really meant this one. The one that for now seems to be producing the right answer for 10. Oh, I know what the problem is. Right. They are like one-off. They're one too many because the final letter, like an N, is part of an N, but is also part of the next count. That's where it gets duplicated. Just counting the final letter. How do I avoid this? I could count one less. Like I could subtract one from the second letter of the rule. Let's see. 1587. Because then I need to compensate for the first letter in the freaking string, where I need to add +1 for that one. Holy shit, this is a horrible off by one error place in a really horrible place. So I'm counting, I count all of the thingies, and then I do counts base dot len -1 minus a plus equals 1. Is that it? What do you know? So I can now change this to a cute 2020 split. What do we think? 2020 seems fine. That looks like my input. Let's see. Oh, you know what? Oh, wait. Let's remove all this debug printing. I want the clean output. So this seems fine. This is not fine. This is not fine. That's it. So we just print for each rule the progress bar, and then we do the final progress bar, which is also kind of useless, but whatever. Should we go release fast? I don't know, because I have a bunch of unreachables that I want them to trigger in case there's an error. Oof, there's a lot of stuff. How are we doing? Is this it? Are we already there? No. Oh my god, how many numbers? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. Okay, so we'll get there in a moment. Maybe I should have done a release fast. You know what? Let's do a release fast. I mean, if it gets to this point, there are no more unreachables. What do you know? Look, release fast is so much faster. Holy shit. Ooh. Let's see. Tell us a story. Well, I don't know. The story... I don't know what story. I actually don't think I have that much time, right? We're almost there. I don't know. I don't know any story. Z lacks a main loop that reactives, removes the necessary print and auto-recompiles fast when needed. So once upon a time, there was this thing, and then oops, it finished. So 1 minute and a half, or 1 minute and something, whatever. Let's see. Oh, it's wrong. Oof. First try. Oh my god. This is actually first try, and what it took me, what, 20 minutes to solve? Well, thank you everyone. So that was funny. Okay, let me think of things that went well and things that didn't go. Things that went well and things that didn't go well with this code. So I think the start was good, and the idea of mixing horizontal and vertical was good. I did not think about counting, memoizing the counts. That's clearly the right thing to do. And in general, the point is, we've seen also in the past, you don't want to have to keep around a string of something. Whenever you can count and keep the counts squished together, you want to do the counts. The problem is that here they made it harder to understand that. Like when you think about the lanternfish was like a very simple example of this concept. But in this case, they made it harder because you need some there are some like spatial constraints based on how the pairs are nested or like laid one next to the other. So you need to look at the rules, or rather, that's how I solved it. And when I understood that I needed to look at the rules, in the beginning I didn't know exactly what to do. So I was thinking that I kind of wanted to macro expand the rules, which was wrong. But then I thought, well, if I don't know yet how I want to macro like expand the rules. But even if I do expand the rules, at that point, what I care about are the counts. And so that's when I said, when I realized that actually, yeah, that was it. In terms of code, I don't think I didn't do too bad. Like, I think I used reasonable data structures for most of this stuff. So the rules, like array lists are fine if you use clear retaining capacity. So this thing is very nice because it resets the array list, but it doesn't free the memory. So it's basically like at that point, it's like it's not dynamically sized, so I don't have to come up with the math of how big this actually should be, like what the max value is gonna be. But then I'm also not paying the price of like resizing these things all over and over. It's just gonna happen once, and when it reaches maximum length, that's where it's gonna stay. And the funny thing is that, like, the nice thing is that you can do clear retaining capacity to both buffers and hash maps, which I ended up not needing, I think. But as I was messing around, I also find out that the hash map has the same API, which is nice. Then what else? That's pretty much it. Also, 2 arrays, absolutely. Going insane with indices, yes. Specs was absolutely right. Only madness lies down that path. Okay, let's see. I built a string for part 1. For part 2, that would have taken 100 days, so I switched to depth first, like you. And then that wasn't fast enough, I memoized it. Oh, I see. So you memorize, like, you memorize maybe some other parts of the expansion. That makes sense too. I solved it with memoization, I see, but there is an even better solution. Well, I think that, like, at the end of the day, I said memoization, but I meant it in a very generic way, so you obviously need to save some partial result to speed things up. In my case, what I did was I don't know, you can call it a somewhat explicit form of memoization, because I didn't have function calls, I just had, like, loops and around. Maybe if I went down the function call path, it would have been easier at one point to, like, say, like, add memoization on top of that. Ooh, let's look at the solution. Yes, thank you, OneNice. Let's look at this. Can I have zoom, please? You zoom in. Command plus, right? How do I do command plus on my on my tiny keyboard? Come on, that should be it, right? Oh no, right. So it's this. Yeah, that's the minus, that's the plus. Okay, sorry, I'm messing around with my keyboard. So import stuff, pair given a string, master count equals 2. Oh, okay, so I see your point. So you string, again, I'm guessing it's like a slice, and then you want an array. Yeah, you want an array. So this is basically the equivalent of me doing where is it? It's basically the equivalent of me doing this, I guess. I have a slice, and then I grab a pointer to an array of 2 elements, and then I dereference it. Okay, then you have your rule. Oh, and then you have your main struct. Place step. So let's see what the comments are saying. Process pairs is the core. Okay, let's look at process pairs. Process pairs. Okay, for each pair and a step, if step equals 0, return An empty result. What's result? Result is exists and value. Okay. Memo.step equals step. Defer result exists equals true. Memo okay. Okay. Where can I see that you are? Oh, I see. This returns like the default result, like the zeroed result. Okay, where can I see where you are? Okay, so here, result is memo key, because if it's 0, there is nothing in memos. If the step is not 0, or rather, okay, I'm not sure. Place puts the next var on top like a union, so that it's like a compute-free hash of step plus pair. Okay, and then for rule, so for each rule, if rule pair 0 equals 0, 0, and rule pair 1 equals P0 and P1. So wait, we are inside another, what's the pairs? Oh yeah, it's recursive. Okay, I see. So you're okay. Yeah, that makes perfect sense. I assume that that's kind of what you were doing. So this makes perfect sense. Is this what I wanted to do? This. Okay, so you're recursing down with process pairs, memoizing as you go, and basically this process, even though like you're potentially going down pretty deep, but at one point you start memoizing well enough that like this starts hitting the memoization immediately, and then you're good at that point, I guess. You can only go 40 deep. Yeah, that's right. That's fair. Oh, right. That's a very good point. Right, and all you do is basically adding one for a specific character. Right. That's actually very reasonable. You know, I used to be very aware of memoization when I used to program in Python. I don't know why I completely lost that way of doing things. Like in Python, it would have been pretty easy. Because like you, in terms of syntax, right, you would have like a process pair function that doesn't even know about memoization, and then you put like a memoize decorator on top of it, and you're good to go. And like you really get basically the same characteristics, roughly speaking. That's cool. Did you also have to do the weird +1 at the end? So let's see. I'm guessing this is this your main function? Yeah, you do the pair, then you add the totals. And then finally for split polymer totals values IT minus char A plus equals 1. Oh, and then you add the polymer itself. So you are not, oh right, because here, okay, this is very similar to what I had in the beginning. I also was counting just the expansion, so I wouldn't end up counting the original string. And then I needed to add the string at the end. That's why it was my original thing. Yeah, so, okay, so basically what ended up happening, this is very interesting. So you have a more functional way of expressing it, and I was avoiding it specifically because I was thinking, oh, I'm doing a systems programming thing, so I should use while loops instead of recursion. But actually, you are totally right. If you go down 40 times, who cares? Do recursion. Do your memoization stuff. Your memoization, you know that it's not going to be giant because it's going to be... You're going down 40. And at the same time, your possible inputs are not that many, like the rules are only so many, so you know that this whole thing is going to be reasonable in terms of resources. And then by having functions laying around, it's easier to set up a memoization and stuff, while if you have a while loop, you need to do so more explicitly, which is what ended up happening to me, because at the end of the day, I'm kind of also doing the same, just expressing it in a really weird way, that then forces me to add the final base because I couldn't count it given how I split stuff up in here. Anyway, you should never use recursion except when you should use recursion. Yeah, right. So I guess the lesson for me from today is it's okay to use recursion occasionally. You seem to prepare all the rules of something. I'm basically doing this, except that I'm doing it in a more in a different way. So basically I don't have functions, but I have a while loop. And actually, you know, let me take this back. Your, I think, is actually I think yours is better than mine, also more in general, but here's the idea. I had this thing where I had a piece of code that was doing that was expanding the string horizontally, so really producing a wider string, and then I had another piece of code that was going down two things at a time. So what I ended up doing is taking the code that was expanding 2 letters at a time and then going deep depth first, and I apply that to the rules. So I have my rules, and then I have my rule scores that basically is like your memo stuff. Like for each rule has a partial count, and I expand each rule 20 times, and at the end of the expansion for 20 times, I put all the final counts for each character into this hash map, so that I have basically for each couple of rules all the scores written down. And then at the end I take the string expanded up to a given point and expanded. I think I did that 20-20 split, so I expanded the string 20 times, and then I expanded each rule 20 times. And so basically the result is like doing an expansion 40 times when it comes to counts. If you then, this is like you have more or less. So it's like, I don't know how I landed into this weird solution. The memoization stuff was kind of nice. So let's see. Look at the solution from XY. I did an eager solution instead of memoizing. Okay, okay, let's look at all these solutions. So let's look at the one from Specs. Eager. Oof. Maybe I can reuse it once more. So what does eager do? Rules template. Pairs are... Okay, what's rules? Rules is... Okay, it's a hash map that goes... Okay, it's the rules in the hash map. Okay, so... Pairs, inserts... Are you doing this to not go through the hash map every time? Oh, whatever, we'll find out. Links. What's a link? A link is left-right pair ID. What? Why is... Specs, is this like a Java Enterprise solution? Okay, so a link is left and right characters. I'm not sure I understand. Why isn't this just a pair? Why is it a different type? Every pair has a dense index in the out-array hash map. A dense index, you mean the pair... So you're saying that to each pair of characters you assign a single value that you store inside a U8, is that it? So for links, counts, so for rule A, B, C, that becomes A, C, B. The links are the indexes of AC and CB, the two child pair. Okay, holy shit. So link left, link right is in cast to U8. Rules get indexed. Holy shit, Specs, how long does this take to run? You know what? I can actually answer this question myself, I guess. How do you do it? You embed file.data 50. Okay. Okay, let's run it. Oh my god, such a flex. Holy shit, such a flex. This is Control N. Oh, do you have stuff that you import from your util zig stuff that I don't have? I think you only use GPA, so I think I can make this. Hopefully. Okay, so let's see what else he's saying. Specifically is so cool. Let's see. Says the expected type mem allocator found type. Wait, then what the heck is GPA? Did you lie? Martin, is GPA not the implementation of... Oh my god, you're a criminal. Okay. Expected type STD mem allocator found type. What am I missing? Oh wait, okay, I see. So it's not the type, you call GPA this. I'm guessing. Wait, is it even init? I don't remember. Has no member called init. Is it just, you just call it? Yeah, look at util.z, I guess. That's the easiest way. Oh wait, it's in here, right? Yeah. Oh right, I was almost right, but wrong. Wrong enough. Okay. I was almost there, just not quite. Okay. Holy shit. What do you know? So day 14. So I think I get part of the point. I really do not get the general thing, but yes, every time you have a pair, the pair expands into two other pairs at a time. What I wonder is, what do you do then with that knowledge? Depth? Counts, link left. Counts, link right. Okay, so let me get this right. I think you are basically treating this as a graph traversal problem, but you are also doing memoization in a sense. It's just that you're doing it in a different way. Do you think is that a fair way of describing your approach? Oh, but 10 milliseconds is kind of slow, I guess. Yeah, I'm eagerly fetching the memorization, so I discard layers when they are no longer needed. Yep. Well, in a way, that's also kind of what I'm doing, but clearly in a way less efficient way than you. Yeah. Okay, you're discarding the layers. That's interesting. Holy shit. Okay. Wait, but this is I see this comment that says better day 14. What was your first way of approaching this? Like, did you go for this solution immediately and just didn't do it nicely? Like, did you clean up, or did you go for something different in the beginning? So let me also time this. Wow. 3 milliseconds, something. So I guess 2.55 milliseconds is the time spent in running executable, I think. Nanometer. This is my very simple 10 milliseconds. Oh, Python solution. Okay, that's nice. Let's see, where's your memorization stuff? Because I guess that's the point, right? Oh, okay, let's start from the main. So rules is empty, put the rules in there. Print the rules. String to pairs. Chars. Default dict. Okay. For C in start, what's start though? What's start? Oh, it's up here, right? Oh, yeah. Right, so for C in start, start incrementing that. Then for 40 times you call do rules. And then for characters in chars, and chars is your, I think it's your final counts, right? If means is none. Oh, this is just finding minimum and maximum, is that it? Okay, let's look at do rules. Do rules. Rules, pairs, chars. New pairs. Okay, I think that's kind of similar to what I was doing, I think. Oh no, I think I see. I do want to share my Python solution. Wait, where's the solution from YX that people were saying I should look at? There we go. .cr. What's CR? .cr? Oh, Crystal. So let's see. Step, solve, inputs, lines. Start is the first line, I guess, and then pairs is start. Okay, so this makes pairs from the original thing. First and last. That's interesting. Inputs.shift. Okay, so this is for parsing the rules. And then solve 10 iterations, solve 40 iterations. Holy shit, also we're doing 3 milliseconds with the spec solution while doing also part 1 at the same time. So solve n times do step rules pairs. Tuple and each. I think that all of us are basically doing roughly the same idea of. I mean, what are you gonna do other than memorize your partial solutions? There's no other way of getting out of that. It's very terse, this solution. Yes, this is crystal, I think. So let me see. What I find interesting is that, like, here your n is 40. So whatever it is that you're doing it 40 times. Oh, because, okay, I get the point. Because I guess you're doing the recursive counting, because the recursive counting can be done 40 times. What you cannot do 40 times is the recursive expansion. Although, you still have to do a lot of stuff, I think. Counts here. I'm guessing this returns counts. So counts is a hash map. It's a hash map from pair to a count. For each pair. So pairs are all the pairs from the original string. Okay. So from each pair of the original string, rules pair.each. So for each pair from the original string, I guess this is this each runs only once, I'm guessing, because there's only, I'm assuming the rules only finds like .each is just a way of doing something from one result of rules, I think. So that gives you the character, and so you increase counts. No, wait, that gives you P. That gives you P? Oh, okay, no, rules give you both. Okay, that's kind of how Specs did it. So that gives you the two expansions, and you increase the count of those expansions. Right. And so you increase the counts for those pairs. What is C though? C comes from... is inside pairs. What the heck is C? Is the count of that pair. Okay, so you do get key value. Right. Right, and then... so you solve n times. So for n times... oh, there we go. You compute everything, put everything in pairs, and then pass it in again n times. And then you do, I guess, the final aggregation. That's cool. There are so many nice solutions. I don't know how I ended up down the path that I ended up down. Whatever. That was fun. That was fun. That was an interesting day of the advent of code. The insight that each pair expands into two new pairs is good, but I couldn't immediately find a way of using it, because the fact that one becomes two, that already smelled to me bad, because there were things exploding in size. But actually you can make good use of it if you know how to cut stuff that you don't need anymore. Nice. I gotta admit I have a weak spot for readable less than 50 line solutions. I mean, I guess. I don't know, I'm actually interested in how much interesting stuff you can do when you have access to the lower level tools. Okay, like this solution from Specs, holy shit, there's a lot of stuff going on. Especially if you compare this to this. But occasionally you can do certain tricks that are so insane. And probably you don't see those in the Advent of Code, because I think the reality is that the Advent of Code is not designed to punish you if you're not programming in a low-level language. Or let me actually flip this concept around. The Advent of Code is, I would say, most probably designed to be solvable if you're a Python or JavaScript or even a slower language programmer. So you basically, I think that the Advent of Code is never going to be able to show the full strength of Zig over a higher level language. But in any case, it's an interesting exploration, at least from my perspective. So I can see for like somebody who's looking for the best tool for Advent of Code, I think that probably Zig is always gonna look a little bit too, I don't know, boilerplatey, maybe a little too mechanical compared to this cute thing. On some days we might get away with brute force solutions with Zig and Rust. Maybe, I'm not sure though, because I think that the designers will definitely want to make sure that okay, so you say maybe you might get away. Okay, that's fair. Although I think that the designers of the Advent of Code will probably not make many solutions that are in that space. There should be an extra level per day with 10 to 100 times the input data. Yeah, so no. Guy, you're good, huh? Oh man. What a day of the Advent of Code. Holy shit. Okay, well, thank everyone for being here. I think that will certainly make Robin happy, yeah. Oh my god. I wonder how Robin's solution looks like. It must be insane. Well, everyone, thank you for stopping by. Let's see, I think we should raid somebody. Who can we raid? All the people that I usually watch are here, so let's see. Let's see who else we can raid. Let's see. Oh, some C programming, I would say, right? Or a blockchain in OCaml. Blockchain in OCaml. Let's not do that. Also, Lucas, sorry, I didn't say hi earlier. I saw your message though. I saw that you were waving in Italian. So, you got here kind of late, I'm sorry. It took me 4 hours though to go through everything. Yid the Need, thank you for the follow and enjoy the raid. Bye bye.